Hello everyone, welcome to Vedantu JEE English. I'm Diksha Ma'am, your chemistry master teacher. So everybody do let me know in the chat box if I'm clearly visible and audible to all of you or not, so that we can start with the session. Yes everyone, I think I'm not visible. Okay. Yes, I should be visible now. Uh, uh, uh. Hello, yes everyone. Oh, yes, now you can see me. Hi everyone, welcome to Vedantu JEE English. I'm Diksha Ma'am, your chemistry master teacher. And how are you all? Everybody do let me know in the chat box. Yes, ma'am, you were audible, not visible. That's kind of ghosty thing that I do here. Right? So, yes everybody. Ma'am, will this be useful for BITSAT? Definitely yes. This will be useful for any kind of exam that you are giving, which includes chemical kinetics, solutions, electrochemistry, and redox reactions, because I'm going to cover these 4 chapters today. Okay, so I'll be starting with which thing? Solution chapter. I will move to this chemical kinetics, then I'll further after that I'll take a break, then we'll have your lunch, and then we'll start with redox reactions and electrochemistry, and that's it. I think maybe by 4 p.m. or 4:30 p.m. we should be like done with today's lecture, right? Okay, yes everybody, tell me. Clear, clear, clear. Clear? Oh, yes. Let me see how many of you are present here. Your attendance, Anjali, Cherry. Now everybody spam the chat box with green hearts. See, I'm giving like 40 minutes to 1 hour to each chapter, right? So you can say 1 hour for solution, 1 hour for chemical kinetics. Then you will have one like 30 minutes, like 20-25 minutes break, lunch break, then hardly 40 minutes for redox and 1 hour for electrochemistry, makes up to like something 4.5 hours. Okay, right? Yes, 100% focus. So just spam the chat box with green hearts so that I can see how many of you are present here. Yes, Bhanushi, Hivani, Revnath, Charan, Varshini, Dildar, Priya, Suga Priya, Krishna, Cherry, Rockstar, Joginder. Very good, very good. Ma'am, qualitative, quantitative analysis. That Anjali I'll cover in your organic chemistry session. Okay, that I'll do there. Okay, yes. Chalo, let's start. Let's start. Let's start with the class. I don't know why I'm getting stuck here. I think wait a minute, okay? I think I need to add something here. Wait a minute. Let me see if that works. I think it should not get stuck now. Yes. Okay, let's start. I want to score. Everything will happen, but now, when is organic chemistry? We'll do organic chemistry after this. Okay, let's firstly do physical chemistry today. Let's complete the theory part. Then 2 days I'll take for numerical practice, right? And after that, we'll do that. Okay? Chalo. Everyone ready? Ready? It's echoing. Is it echoing for other students as well? I don't know why there is so much disturbance here. Wait a minute, let me see why it is echoing. Is it for everyone? Wait a minute, let me see. It should not be. Wait a minute. Let me see what you are listening to. Wait a minute. Okay. Wait a minute. Let me see. What is it? Oh my God. Okay. Now let us see. Now is it echoing? Now I think it should not be. Let me just. Hello. Okay. Now let us see. Now is it echoing? Okay, now it's fine, right? Okay, perfect. Perfect. Yes, now everything is fine, right? Okay, now let's start. Right, thank God you told me in the starting. Right, any other problem? Right? Okay, I think my video will get stuck in between. I don't know what's the problem here, right? But I am trying to see if there is like, I have tried to eliminate the problem, but if it is there, then do let me know, right? Actually, before you, I will only see that whether it's stuck or not, right? But still, if I'm not able to see, just put green heart, spam the chat box with black hearts if you see I'm stuck somewhere, okay? Chalo. Now let's see and let's start. So guys, in the first go, we have solution chapter, right? Class 12 solution chapter here. So now in the solution chapter, what we are going to do here, let's see that. In the solution chapter, how we are going to do the things. In the solution chapter, we are going to start with the very starting of this, that is the types of solutions that are there, right? But before that, let me tell you, in the solution chapter, you will have a category that is binary solutions, right? First thing is, ma'am, to answer that, ma'am, what are all the topics that we will study in solution chapter? So how many of you know the topics that we will study in solution chapter? Tell me, what are the topics that you will study in solution chapter? First topic is, guys, first you will study about like types of solutions, right? Then you will study about solubility, right? Then we will discuss 2 3 laws here, that is Henry's law. Then we will discuss Raoult's law, right? We will also discuss Dalton's law, okay? Dalton's law. These are the small topics. Now from there we'll switch to ideal and non-ideal, ideal and non-ideal. Then we will switch to positive and negative deviation, then azeotropes, then very important topic, that is colligative properties and Van Hoff, right? So these are the topics that we are going to do today, right? Okay, so one by one we are going to summarize this, right? So we are going to start with the types of solutions first. To understand the types of solutions, see, there are two things, one is solute, one is solvent. Solute is in less quantity and solvent is in high quantity. For example, you have made sugar solution, so you will add 1 glass of water, you add 1 tablespoon of sugar in it, that is sugar solution, right? Where sugar is the solute and water is the solvent here, and solute plus solvent together will make up solute plus solvent, it will make up together solution. Now what are the kind of solutions that we are going to discuss? There are so many kind of solution, binary, ternary, quaternary. So we are going to discuss about binary solutions. Binary solutions means which has one solute and one solvent. Ternary solution means you will have two solute and one solvent. Like in the glass of water, you have added, let's say, 1 tablespoon of sugar and 1 tablespoon of salt as well. That is ternary. Quaternary means where 3 solute will be there and 1 solvent will be there. So total 4. That is quaternary. But we are going to discuss about binary solutions where you are going to have, okay, no problem, where you are going to have 1 solute and 1 solvent here, right? 1 solute and 1 solvent here. So now those solute and solvent can be anything. For example, if I am saying that, ma'am, solute is gas, let's say always the solution name is designated by the name of the solvent here. So let's say the solvent is gas. If the solvent is gas here and you take solute as gas, so it will be gas in gas kind of solution. If you take solute as liquid, it will be liquid in gas, like you have gas in liquid, liquid in gas. Then gas is the solvent, that is in big amount, and solid will be the solute here. Now examples are, gas in gas means like you have air, right? In air you have so many gases that are mixed together, right? So we say mixture of oxygen and nitrogen gas, right? That is the gas in gas. Then you talk about liquid in gas. So chloroform is a liquid that is mixed in nitrogen gas, that is liquid in gas. Then solid in gas is like camphor, that is a solid that is mixed with nitrogen gas, that is solid in gas. Okay. Then when your solvent is liquid, and solute can be gas, liquid, solid, anything, right? So gas in liquid, it is also Coca-Cola bottle that you have. In that, carbon dioxide is mixed in the high pressure in that thing. So you can say oxygen dissolved in water as well. In the ocean, right, there is oxygen also dissolved in the water, in the ocean water, where it is also there. That is how aquatic life is able to breathe, right? So next is liquid in liquid, anything you add, milk and water, right, that we see in our home, right? Adulteration. So milk and water are mixed together, that is your solute in that is liquid in liquid. Solid in liquid, so you mix sugar particles in any liquid, that is called as your solid in liquid, right? Then if your solvent is solid, right, that means in big amount you have solid, so that can be gas in solid, that means hydrogen gas in platinum. So this is also a catalyst, right? Nickel, platinum, these are catalysts where hydrogen gas is dissolved for hydrogenation, right? So that is gas in solid. Then guys, we have liquid in solid. So liquid is in small amount and solid is in big amount. So any amalgam, sodium amalgam, you can say zinc amalgam, that is put in mercury with sodium. That means what exactly we do in zinc amalgam, we put zinc, that is a solid, zinc, that is a solid, and we add small amount of mercury, that is a liquid, right? Then solid in solid, you talk about any alloy, brass and all, these are these alloys, that solid in solid mixture, it is called as your solid, solute and solid, solvent. Okay. Now let's talk about solubility here. Now let's talk about solubility. Now who will tell me what exactly is solubility? Anyone of you? Anyone of you who can tell me what exactly is solubility? Anyone of you? What do you mean by solubility? Tell me. So what you will have here? Yes, solubility is a thing where I am saying, let's say I have a glass of water. I'm adding sugar into it. I'm mixing it, so it is getting dissolved. Now there will be a point that in a certain amount of water, there is certain amount of sugar that I can dissolve, right? That is called as solubility. That means if I have a cup of water here, how much sugar can be dissolved in this specific amount of solvent, that is called as solubility of that solvent at constant temperature and pressure. Mind what I'm saying. I am saying I am not changing the pressure, I am not changing the temperature. These conditions are same, right? At a given temperature and pressure, how much liquid can dissolve how much amount of sugar or any solute into it. That is called as solubility, right? Now we say there are certain kind of things, that is saturated solution, unsaturated solution, and supersaturated solution. So three kind of solutions I talked about. One is saturated, other is unsaturated. So the unsaturated solution and saturated solution, let's talk about that. First is unsaturated solution, where you can like, okay, I have glass of water, I added 1 scoop of sugar into it, okay, it is getting dissolved easily, so it is unsaturated. Now right now you are in an unsaturated situation, you're like completely fresh in the morning, you're like, okay ma'am, we want to study, you are in unsaturated solution, in unsaturated state, like, okay, I can study more here, right? So when a solution can dissolve more sugar into it, more solute into it, that is unsaturated. Then it will go to saturated state. Can you tell me what is a saturated state? Now after 5 hours of class, you will be like, ma'am, oh my god, ma'am, I'm done, ma'am, okay ma'am, now ma'am, I can't study, I need break, right? Now you're in a saturated state, ma'am, enough for today, ma'am, I am not able to study more. But then you remember, now that is your saturated state where no more solute can be dissolved. Your limit has crossed, right? Now supersaturated will be, tell me what will be supersaturated? It will be a state where you are like, huh, I am so tired, but I have to study. I have my exam in 10 days. I have to study. I'll study physics. I'll study math. Why? Because I have my exam. Chemistry part is done today. So that is super saturated. Your brain is drained already, but still you are forcing yourself to study. That is super saturated. That means no more solute can be dissolved in a saturated solution, but then you forcefully dissolve the sugar. That is called as super saturated solution. Tell me, is that clear? Is that clear to everyone or not? What is unsaturated? What is super saturated? What is saturated, right? Okay, done. Now let's understand rate of dissolution and crystallization. Why I'm saying that, why I'm teaching you these things in detail in rapid revision as well, because they ask you statement based questions, right? So that is why I'm focusing on every single thing. You can't avoid anything. You can see it from the JEE attempt 1, right? So all the questions that you thought are not important are being asked, right? So rate of dissolution. So if you see this here, right, this is a beaker. Okay, this is a beaker where I have, let's say water. I have water in it. These are the water molecules that I have. Dhyan se, listen to this very carefully. Listen to this very carefully. I'm not going to repeat this again and again. So listen to this. And if you ask me, ma'am, repeat, mention which point you are not able to understand. Okay. See. Now if you see this here, this is water. These are water particles, water molecules. Now I am saying you added sugar into it. Okay. You added sugar particles. I'll just add sugar particles here. Okay. These sugar particles are getting dissolved. These all sugar particles are getting dissolved. Okay. I added sugar particles. It got dissolved. Till here everything is clear. Now it has reached its saturated solution. Now it is like, I can't add more sugar. I can't add more sugar. My limit is done. I can't add. I am like, how you cannot add? I will add more sugar. Okay. You added more sugar and I am representing it by red. So you added more sugar into it. So I am adding more sugar. 1 particle, 2 particle I added. Now to my eyes, the sugar particle that I added is not getting dissolved because it is saturated. But in reality, what is happening? In reality, this after it has reached its saturated state, when I add another sugar particle, it will get dissolved, this will get dissolved, this will get dissolved, but some already dissolved sugar particle, some already dissolved sugar particle will get crystallized here. So if you add two extra sugar molecules, two already dissolved sugar molecules will get crystallized here. That is what we say rate of dissolution. That means at which extra sugar particles are getting dissolved is equal to the same amount of sugar particles that were being dissolved are getting crystallized. So these two got dissolved, these two got crystallized. So this rate is same. Okay, tell me, is that clear? Is that clear? This is all written in your NCERT. Okay, done. Tell me. Okay. Okay, Rockstar, no issues. Right, tell me. Done. Now let's focus on the effect of temperature and pressure here. Right? Okay. Ma'am, you told that, Hana, I think you have not watched yesterday's session. We did class 11th yesterday. Today we are doing class 12th and tomorrow I will do it. Right? Because it went really long. Right? Now please, can we focus, guys? Can we focus? Hana? Right? I'm in such a good mood. Don't spoil it and focus. I'll just end the class. Okay? You have no idea. There is a Kali Mata inside me. Right? So, if you are not replying, if you're talking like all these things here, right? Mr. Hangama, right? Get out from here, right? And yes, other students who are serious here, reply in the chat box, and those stupid, useless people, unemployed people, you can go out, right? There is no need for us to have these kind of live watching where students are not even interested, right? I would love to teach less students with more passion rather than more students talking nonsense in the chat box, right? Okay, I do care about my students and I know that this time is very important for them. So don't do all these things in the chat box that take out their focus and I'm not able to see their doubts. Because for me, the passionate students, the students who are actually wants to study, they are important for me and I want to see if they have any doubt. I don't want their doubt to get somewhere lost in your random stupid chats. Okay? Yes. Done? Chalo. Done. Okay? Yes? Okay? Done. So now let's see effect of temperature and effect of pressure. Now if you see solubility of solids in liquids, now I am talking about here solids. That means I am talking about sugar in the liquid, in the water. So in this case, temperature will have what kind of effect? Temperature in case of endothermic and temperature in case of exothermic. In case of endothermic, it will be directly proportional to the solubility, right? That we discussed yesterday as well, based on that how temperature depends upon the, see, basically temperature is directly by Clausius Caprian equation, it is directly proportional to K, that is equilibrium constant. Here we are talking about solubility, so it will be KSP, and KSP is directly proportional to solubility, so you can directly write here temperature is directly proportional to solubility. For exothermic, temperature will be inversely proportional to solubility. This we also studied in Lee-Chartlier principle, right? There we talked about equilibrium constant. Here we are talking about the solubility. Okay? Aha. Yaar, what is happening here? So many distractions, huh? Okay, so I'll just explain it again. I'm so sorry. Effect of temperature. So effect of temperature we will talk about when it's in case of solids and liquids, right? Then we talk about effect of temperature different in endothermic and different in exothermic. In case of endothermic reaction, temperature is directly proportional to solubility. In case of exothermic reaction, temperature is inversely proportional to solubility here. Right? Why solubility? Because see, temperature is directly proportional to K. K is nothing but KSP, and KSP is directly proportional to solubility. So we can directly say temperature is directly proportional to the solubility here. Then effect of pressure. Now in the case of pressure, solids are incompressible. So when you like apply pressure or lessen up the pressure, because solid does not have any effect with the pressure, that is why here effect of pressure will not be there in case of solids in liquid solubility. Now let's talk about gases in liquids. Gases in liquid means like you have Coke or all these Coke bottles, Fanta, Limca. In all these cases, you have gas that is dissolved in these soda bottles, right? So in all these cases, you have gas that is dissolved in the liquid, right? So now gas is dissolved in liquid. In that case, we can say that firstly what will happen in case of temperature. So when you increase the temperature, molecules will move away from each other. That means their solubility is going to decrease in this case, isn't it? Can I just directly write here? Everyone tell me. So in this case, you can say temperature is directly proportional to, or you can say solubility will increase as temperature, solubility will decrease as the temperature increases. Okay. Why? Because when you increase the temperature, molecules will move away from each other and their solubility, their interaction will decrease. Right? Now in the case of pressure, when you apply pressure, molecules are coming, when you apply pressure, molecules are coming closer to each other. So when they are coming closer to each other, their solubility will increase. So we can say pressure is directly proportional to solubility, right? Or you can just write it here only, that it is directly proportional to pressure, right? And from this, from pressure directly proportional to solubility, we have which law? Henry's law. We have another law, that is Henry's law, right? Okay. Now we are moving towards Henry's law here. So we have discussed everything here. Now we are going to talk about Henry's law. Let's talk about that. Henry's law says the same thing that we have discussed here, that pressure is directly proportional to solubility. As the solubility increases, the pressure increases, solubility will increase. That is correct. So he is saying that, let's say, Henry said that, let's count solubility as mole fraction. So more is the mole fraction, more will be the solubility. So the factor of solubility, we can write it as mole fraction as well, isn't it? Now here what we will say, because pressure is directly proportional to the mole fraction, now erase the proportionality sign and you will have Henry's constant, that is Kh, and this will be mole fraction, and that is your Henry's law. Right? Now there are some important points regarding Henry's law, and that is different gases have different Kh values. We are saying that different gases, like you talk about hydrogen, helium, lithium, H2 gas, lithium is not a gas, hydrogen, helium, then you talk about oxygen gas, nitrogen gas, methane gas, carbon dioxide. So all these gases will have different value of Kh, and their Kh value will depend upon which thing. This is a very important point that they can ask you in your JEE, because these kind of tricky questions are asked to you, right? So different gases have different Kh value. Kh is a function of nature of gas. Yes, that's why different gases have different value. Higher the value of Kh at given pressure, lower is the solubility. That means we are saying Kh is inversely proportional to solubility. If I state that, you know how they will give you the question here? They will give you 3-4 values. They will give you gas A, gas B, gas C, gas D. They will say, let's say the order of KH is A, then you have D, then you have B, then you have C. This is the order of KH. So solubility will have opposite order. Solubility will have opposite order, right? This is where you will use it, right? Then KH values of a gas increases with increase in temperature. Now, if you talk about when the temperature is increased, the KH value will increase, and this is a very important conclusion that you must know. Okay, this is a very important conclusion, right? Done. Now, let's talk about this. That is Raoult's law, right? Understood? Henry's law understood now? We will do questions in the next class based on these things, right? Now let's talk about Raoult's law. Raoult's law states that if you talk about two things, one is partial pressure, other is vapor pressure. Now first you should know what is the difference in partial pressure and vapor pressure. So I will teach you here only. What is the difference in partial pressure and vapor pressure? Let's talk about that. Okay. So see, this is a rough page that I am taking. So if I talk about partial pressure and vapor pressure, right, or shall I? So I'll just teach you here only. Wait a minute. Now see this. Now if I say that I have a beaker, this is another beaker, and this is a mixture of these two beakers. Okay. Now in this case what I have A. This is component A. Okay. This is component A. Right. Then here I'll have component B. Here I'll have component B. Right. Isn't it? Here I'll have component B. So you have component A and you have component B. You can write it over here. This is component A and this is component B. Right? Now, when I mix these two components, that becomes A plus B. Now, I am saying that these are volatile. Okay? Volatile means this also will have some kind of vapors, and these vapors will be here. It will make A kind of vapors. This will make the vapors of B, vapors of component B will be here. And in this case, you will have both A and B. In this case, you will have both A and B. This is A and this is your B. Okay. So you'll have both A and B, and you will also have vapors of both A and B. So these are the vapors of A and these are the vapors of B. These are the vapors of B. Now see this thing, if I talk about this thing here, that the pressure exerted by the component A when it is in its free state, when it is in its pure state, when it is not in the mixture state, this is called as P naught A. Okay. When I say that it is in the B is in the pure state, that is called as P naught B, and this is called as, here the vapor pressure caused by A will be PA, that is partial pressure, because now it is in the mixture state. So some hindrance will be created here, right? And here for B it will be P naught B. Sorry, it will be PB, right? So we can say P total is going to be equals to PA plus P, right? Is that clear to everybody or not? Tell me. Is that clear, everyone? Is that clear, everyone? Tell me. Is that clear? Okay. What is P naught A? So this P naught A and P naught B is called as vapor pressure. Vapor pressure in the pure state, or you can simply say vapor pressure. But PA and PB is called as partial vapor pressure. Partial vapor pressure. It is called as partial vapor pressure. Is that clear to everyone here? Is that clear to everyone here? Shall we move ahead? Right? Okay. So now it is very simple for you to understand that if I talk about Raoult's law, it says that this partial pressure here is equals to P naught A, mole fraction of A, and this PB is equals to P naught B, mole fraction of B. And that is why total pressure will become equals to PT will become equals to P naught A mole fraction of A plus P naught B mole fraction of B, and that is called as Raoult's law. This is called as Raoult's law. After solving, this is the kind of formula that you will get for Raoult's law. Okay, this is the kind of formula that you will get for Raoult's law. Right, that is PS, that means PT only. You can also write it as PT. I'll just write it as PT because we have understood it as PT only. So I'll write it as PT only. So this is PT, that is equals to mole fraction of A. You can say mole fraction P naught minus P naught plus P naught. AABB. Okay, that's how you can remember this as it is. If you don't want to remember this, even if you remember this one, that is also fine. Okay. Now, let's talk about Dalton's law. Now, guys, here we are talking about Dalton's law, right? Now, tell me, just give me a second, guys. I'm getting one call here. Wait a minute, just. So sorry. Yes. Okay. So, yes, everyone. Yes. Now see the students that Dalton's law, if I talk about, in this case we talk about YA, right? Here we are talking about XA. Now the question is, what is this YA and what is this XA? Let's talk about this here. I am writing this here only. X is representing mole fraction, or you can say chi is representing mole. This is actually X is nothing but it is called as chi. It is representing mole fraction in liquid phase. In liquid phase. And Y is the mole fraction in vapor phase. That means I can say the mole fraction that you have used here, the mole fraction that you have used here and here, all of these are the mole fraction in the liquid phase, in this phase, in the liquid phase, in the liquid phase. But here in the Dalton's law, I am talking about mole fraction in the vapor phase. Vapor phase means this phase. This phase is vapor phase. This is the vapor phase. This is the vapor phase. So in the vapor phase, what is the mole fraction, right? That will be defined by this law that is called as, wait a minute. This is how we write it. Here the law is partial pressure of A is equals to mole fraction of A, and this is total pressure, right? And after solving this one and this one, we get this as the formula, right? After solving these two things, we get this as the formula, that 1 by PT is equals to mole fraction. See, if they ask you, you have to apply the formula. Now, this is very important. This is the relation of PT, P naught A, P naught B, and mole fraction of A and mole fraction of B in the liquid phase. This is the relation of P naught A. Again, you can say PT, P naught A, P naught B, YA and YB. That means mole fraction in the vapor phase. So if they give you mole fraction in vapor phase, then you will apply this law, right, to relate it to PT and P naught A and P naught B. I am not doing the derivations, guys, okay? I am not doing that, right? If you have to relate mole fraction in liquid phase, then you will use this formula. Is that clear to everybody here? Right? Okay. Yes, very good, very good. Tell me, is that clear? Is this page clear to everyone here or not? Right? Okay. Tell me. Okay. Now let's see, guys, ideal and non-ideal solutions, right? Now, based on the Raoult's law, we'll tell that like we have so many rules in our society. The one which follows those rules are ideal persons. Similarly, ideal solution is which obeys Raoult's law, right, over all the concentration range. AB interactions, it's like there are some students here who are like totally focused on like the board, what Diksha Ma'am is teaching, everything, like full focus is there. To them, it doesn't matter only that whether there are people who are studying or not, what is going in the chat, they are just happy to interact with me. They are ideal students, right? So AB interactions in solutions are same as original AA and BB. These are those kind of students when if I tell them that you will study alone with me, right? That means you and me, I'll teach you one-on-one, right? They will have the same concentration. And now when A and B interactions are there, you guys can also interact with each other. Then also the concentration, the power is same to which they are studying. That means AB interactions are equal to AA and BB. When you're studying alone, same focus. When you're studying with each other, same focus. That is the ideal situation. It rarely happens, right? So ideal situation, in this case, delta H mixing is 0. In this case, delta V mixing is 0, right? But in this case, non-ideal solution, they do not obey any Raoult's law. They say that AB interactions are not equal to AA and BB. When you're studying alone, your concentration is on different level. When you're studying with each other, your concentration is on a different level, right? Here delta V mixing and delta H mixing is not equal to each other, right? Now, let's see, guys, if I talk about positive and negative deviation here, right? The graphs will be like this, okay? Now, non-ideal solutions are divided into two parts. One is ideal solution, other is non-ideal solution. So, two parts they are being divided into. One is ideal and the other is non-ideal solution. One is positive deviation and other is negative deviation here. So in the case of positive deviation, what will happen? In the case of negative deviation, what will happen? Positive deviation, everyone is like, oh my God, what is happening? Positive deviation, that simply means one thing, that you are being positively deviated, right? That means you are like, oh my God, I was studying alone, I had some problems which I was not able to ask. Now I am studying with my friend, right? AB interactions are there. But I am not interacting with him. Rather, I am taking him as a competition. That way, because how much time he is studying so much more, so I'll get motivated. That means there is positive deviation. Your interactions are less. You're not chit-chatting, but still there is competition within you, so that you can, use more potential here. So that is called as positive deviation, where AB interaction is not. They're not interacting. That is where they are studying more, right? So AB interactions are less, that is why there is positive deviation. Positive deviation means one more thing, that PT will be greater than P naught A mole fraction of A plus P naught B mole fraction of B. Delta H delta V mixing is greater than 0. In negative case, AB interactions are higher than AA and BB interactions. That means their interactions are so much higher that you're chit chatting with each other. Hi, how are you? This, give me your Insta ID, this and that. You're not focusing only. So when your interaction in the chat will be so much higher with the other students, not with me, with the other students, you all will be negative deviated. You will have less marks, right? So negative deviation, if more interaction is there, that means delta H and delta V mix is less than 0. That means PT is less than P naught A mole fraction of A plus P naught B mole fraction of B. Now remember one thing, whether you have ideal gas, ideal solution or non-ideal solution, always delta S will always, delta S mix will always increase, delta G mix will always decrease. In this case as well, delta S mix will always increase and delta G mix will always decrease, no matter what kind of solution you have. Okay, done. Now, if I talk about the graph here, this graph, this graph, this graph is for ideal. In positive deviation, it will be uplifted here, right? And in the negative deviation, it will go in the downside. Okay, that will happen. That is the graph change, right? Okay. Now let's talk about the next thing here, that is positive and negative deviation examples, right? Now let's talk about the examples of positive and negative deviation. Examples, let's see. This you have to remember yourself. All I can tell you is in positive deviation, the interactions will decrease. Hydrogen bonding will decrease. Here hydrogen bonding will decrease. Here hydrogen bonding will decrease. Here hydrogen bonding it will decrease. Here dimerization was happening, but because of toluene it will decrease. Hydrogen bonding will decrease. Hydrogen bonding will decrease. Here hydrogen bonding will decrease. So here interactions are going to decrease. And in this case, interactions will increase, right? In all these cases, you will find out that interactions will increase. It is very, very important to note down the examples of positive and negative deviation. This part you have to do yourself. Okay? Understood? Yes, everybody? Yes. All the examples are important here. All the examples are important. You will see all these examples are asking, they are asking you, that's why all these examples are important, right? Okay. Now, next is azeotropes. Now, let's talk about this. Now, but just see this. If I talk about, firstly, before understanding azeotropes, tell me what is boiling point. Now, when I talk about the boiling point means the vapor pressure of that liquid will make vapors. The vapor pressure of that liquid should be equal to atmospheric pressure. When this point is reached, it is the boiling point. So this is the vapor pressure of the, this is the atmospheric pressure. This is the vapor pressure of the liquid. When you will boil it, when you will give it heat, it will start making more vapors, more vapor pressure. Now temperature is further increases, more vapors, more vapor pressure, more vapors, more vapor pressure, temperature is increasing, more vapors, more vapor pressure, and at one point it will be equal to atmospheric pressure. That temperature is called as boiling point, and it is different for different these different solutions, different compounds, right? Now, ma'am, what is the relation of boiling point with the azeotropes and positive negative deviation? See, azeotropes, firstly, what are azeotropes? The binary solution, that means one solute, one solution, binary solution that have same compound. Binary solution means what you will have, you will add two solutions here, like nitric acid and water you have added, ethanol and water you have added. That means two compounds you will mix, right? Binary solution that have same composition in liquid as well as vapor phase. That means their mole fraction of A and B in the liquid phase and mole fraction of A and B in the vapor phase, both are equal, right? They should have same composition in the liquid and vapor phase. Then boils at constant temperature. We are saying, now let's talk about nitric acid and water. It will have different boiling point, this will have different boiling point. Azeotrope is a thing where both will be combined in such a composition that they will now start boiling at same temperature. That is called as azeotrope. Two different compounds with different properties, when you mix them in a certain composition, they start boiling at a constant temperature. That is called as azeotrope, right? Now, because we are saying it boils at constant temperature, that is why fractional distillation you can't use to separate these two mixtures. Fractional distillation, you need different boiling points. Boiling point is constant, that is why you can't use fractional distillation here, right? So you can say no fractional distillation, no fractional, or you can say not separated by fractional distillation. Okay, now tell me one more thing here. Okay, they are not separated by fractional distillation, that is clear, ma'am. But ma'am, how it is related to negative deviation? Let's talk about this, right? How come it is related to fractional distillation? It will be uploaded. Yes, it will be uploaded, right? Okay. Ma'am, wait a minute. The binary solution that have the same composition in the liquid and the vapor phase. Yes, I'm sorry. Yes, you are right. It should be mole fraction of A in the liquid phase is equals to mole fraction of A in the vapor phase. Mole fraction of B in the liquid phase is equals to mole fraction of B in the vapor phase. Okay, yes. Now see this, how boiling point is related to this boiling azeotrope is related to a negative deviation. See, if I say vapor pressure, earlier vapor pressure was this, right? This is atmospheric pressure. Earlier this much temperature was needed, right, to reach the boiling point, right? Now in the positive deviation, vapor pressure has increased. Now this much temperature is needed, that means temperature is less. So earlier vapor pressure was more, and now vapor pressure, when it is increased, boiling point is decreased. So I can say this, for the positive deviation where vapor pressure is increased, minimum boiling azeotrope is used because boiling point has reduced here. In the case of this negative deviation, earlier this was the atmospheric pressure, this is the vapor pressure. Earlier this much temperature was required. Now I decreased the vapor pressure in negative deviation. Now more temperature is required. That means maximum boiling azeotrope here. Tell me. Done? Clear? Done, everyone? Okay? Yes? Tell me. Okay? Now let's talk about colligative properties, right? Understood, everybody? Shall we talk about colligative properties, everyone here? Let's talk about colligative properties. Let's talk about that. Okay? Shall we? See, 4 colligative properties are there, right? Colligative properties, firstly, what are colligative properties? In which the colligative property is that property that depends upon the solute, how much amount of solute that you have used. It can be dependent upon the solute in different ways. So total you have 4 colligative properties. One is relative lowering in vapor pressure. Second is elevation in boiling point. Third is depression in freezing point. Then there is osmotic pressure. So total 4 properties we have here, right? Now, firstly, I'll talk about relative lowering in vapor pressure. Now, see this thing, how we will do that. Relative lowering in vapor pressure simply means that if I say non-volatile, in all these cases, what we are doing, we are adding non-volatile solute here. Non-volatile solute is added. In all these cases, we are adding non-volatile solute here. Now, in the lowering in vapor pressure, understand one thing. It's like you are going to meet your favorite celebrity, right? Anyone. What's your favorite celebrity name? Anyone, right? You're meeting them. Now, what can happen that if the celebrity is alone, right? There is no bodyguards and all. You can easily meet them. But if bodyguards are there, it will be difficult for you to meet them, right? Because they will restrict you that you can't go here, you can't go here, right? So same thing is happening here. You have solvent, that is your celebrity, right? Vapor pressure are easily getting formed, easily vapors are getting formed. Now you add non-volatile solute, which are the bodyguards. They're like, I can't form vapors, then how it will form vapors? I will not let him form vapors. So when non-volatile solute is added, the solvent which was earlier forming more vapors now will start forming less vapors because of the restriction caused by these non-volatile solute particles, and that is why lowering, dropping in vapor pressure will happen, right? So we are saying initially, let's say you have P naught, that means initially P naught is the vapor pressure in the pure solvent state, and PS is the vapor pressure when you have added non-volatile solute. So initially, because vapor pressure is decreasing, it should be P naught minus PS, that is the lowering in vapor pressure. When you divide it with P naught, that becomes a relative lowering in vapor pressure. Okay, so I'll just write. Oops. Okay, no worries. Okay, so I'll just write it here. Okay, see. If I say this one will be P naught minus PS, that is the total, divided by P naught, that is the pure. It is equals to mole fraction of solute. Solute is represented always by 2 and solvent is represented by 1, right? So this will be 2. Now this thing is nothing but it is equals to N2 by N1 plus N2, right? That is solvent plus solute, that is the total number of moles here, right? Now I can also write this as, now this is P naught minus PS by P naught, right? So you also know that if, we also know if N1 is N1 is solvent, is very large as compared to N2, because usually solvent is very large as compared to solute, right? Then you can write it as, then this can be changed as P naught minus PS by P naught equals to N2 by N1 equals to W2 by M2, and this is W1, this is by M1. And this is the whole thing that you will have. Okay, this is the whole thing that you will have here, right? Tell me. Is that clear? That is relative lowering in the vapor pressure. Is that clear to everybody? Now let's move for elevation in boiling point. Elevation in boiling point, here I'm going to tell you a different story, a different thing related to the same thing that we have discussed till now. See, I'll also make a graph here, right? Wait a minute. Wait a minute, okay? Let's see. Okay, see. Now, what was boiling point? Everybody tell me what was boiling point. Boiling point is that state where the vapor pressure is equal to the atmospheric pressure. That is the boiling point. Okay. Now, we know that vapor pressure is decreasing. Initially, the boiling point is, now I'll teach you it this way, right? Initially, let's say this is the atmospheric pressure. Let's say this is the atmospheric pressure. I'll just put a line here. This is the atmospheric pressure. Okay. And the vapor pressure of pure solvent is higher, or tell me, vapor pressure of pure solvent is more or vapor pressure of solution is more? We have discussed that vapor pressure of pure solvent is more than vapor pressure of solution because vapor pressure is decreasing. So this is the vapor pressure of solution, right? This is the vapor pressure of, let's say, okay, let's consider vapor pressure of solution as this one. This is the vapor pressure of pure solvent. Pure solvent, I'll just put it here. This is the vapor pressure of pure solvent. This is, let's say, this is P naught. Okay. This is the vapor pressure of, wait a minute, I'll just put it here, that is P naught. This is vapor pressure of pure solvent. Now vapor pressure has decreased. This is the vapor pressure of solution and this is the atmospheric pressure. Okay, that is the atmospheric pressure. Atmospheric pressure. Now tell me, when I talk about this thing here, when I talk about this is the atmospheric pressure, this is the vapor pressure of pure solvent. This much boiling point is needed. So this is the boiling point before, right? That is TB naught because it is about pure solvent. This is TB naught. Now we are talking about the boiling point when the vapor pressure has decreased, that is TB. So can I see there is elevation in the boiling point? You can see it directly from here, there is elevation in the boiling point, right? Because boiling point has definitely increased. So you can say TB is greater than TB naught, right? So TB minus TB naught is equals to delta TB and delta TB is equals to molality into KB, right? Okay, and what is the formula of molality? Molality is delta TB. Molality is nothing but number of moles of solute. Number of moles of solute is W2 by M2 divided by weight of solvent. If it is in grams, it will be multiplied by 1000 multiplied by KB. This is, we have already discussed the concentration terms in the last class, that is yesterday's class. I'm just applying that here, right? Can we see? This is the formula that you will have, isn't it? This is the formula that you will have. Now, let's talk about what is this KB, ma'am? What is this KB, ma'am? What is this KB? This KB is nothing that is molal elevation, elevation constant, or you can say, or another name is elebioscopic constant. Okay, understood? That is the name here. Now what is the formula of KB that you have? KB is equals to R is universal gas constant into molar mass of solvent multiplied by TB square, that is this temperature, the temperature of solution, like the boiling point of solution, divided by 1000 into delta H vaporization. This is the formula. Now usually students don't remember this formula, but you must remember because anything they are asking you from there, right? Okay, understood. Tell me, this and this point is clear to everybody here or not, right? Shall we now move towards the third colligative property, that is freezing point? If there is any problem in first two, then do let me know in the chat box. If there is any problem in the first two, then do let me know in the chat box. Let's talk about the third colligative property that we have, right? That is depression in freezing point. That is depression in freezing point. Let's talk about that. What will happen in the case of depression in freezing point? Now, depression in freezing point, for that you must remember what exactly is freezing point, right? Freezing point means vapor pressure should be equal to vapor pressure. So freezing point you must remember firstly. In this case, vapor pressure should be equals to vapor pressure of solid. When the vapor pressure of liquid is equals to vapor pressure of solid, that is called as freezing point. Okay. So now I'll make the same chart here. Let's see firstly, tell me freezing point of liquid, vapor pressure of liquid will be more or solid? Liquid will have more vapor pressure because it is going to form more vapors. So the solid vapor pressure will be somewhat here. This is the vapor pressure of the solid that we should match, right? This is the vapor pressure of pure liquid, that is solvent. This is the vapor pressure of, because vapor pressure has decreased, okay? So you can say if this is the vapor pressure of pure, if this is the vapor pressure of pure liquid, I'll make it here. Now this is the vapor pressure of pure liquid, right? And solution, vapor pressure of solution will decrease. So this is the vapor pressure of solution. Now see, this is the vapor pressure of solution. This is vapor pressure of solution. This is the vapor pressure of liquid, pure liquid. And this is vapor pressure of solid, which we want to equate it to. Now, if you see in the same way, when I talk about P naught and this becomes equal, it is this situation. Wait a minute. Oh, ulta I have written. Wait a minute. Wait a minute. Wait a minute. This, wait a minute. This is, wait a minute, guys. This is vapor pressure of solid, that is less than vapor pressure of liquid. This is the vapor pressure of pure liquid. Yes. Vapor pressure of this is pure liquid, right? And the vapor pressure of solution will be lesser than pure liquid. So this will be PS. Okay. That is the situation. Now if you see when P naught is equals to this, that will become TF naught and this is TF. Now can you see that TF is, now can you see this here, that TF naught is greater than TF, right? That means delta TF is equals to TF naught minus TF. If you see this here, delta TB was TB minus TB naught. Here delta TF is TF naught minus TF. So that is opposite, okay? Then we know that delta TF is equals to molality into KF, right? Now let's talk about delta TB. Delta TF is equals to molality is what? W2 by M2 multiplied by W1. This is 1000. Then this is KF, right? This is a full-fledged formula that you will have here. Now if you see, what is KF here? Anyone of you, what is KF here? Kf is nothing but that is molar depression constant, molar depression constant, or this is molar depression constant. One another name is cryo. Everyone is crying. Cryoscopic. Depress is depressed. No, so depression and we cry in depression. So cryoscopic constant, right? And the value of this is Kf equals to R into M1 into Tf square divided by 1000 into delta H of fusion, because here melting is happening, and that is the entire three properties. Tell me if there is any problem on this page, do let me know, right? Tell me. So, questions I'll teach you na in the next class, but there I'll not teach you all these formulas, and I'll start doing questions. See what happens now when I teach the theory, then I jump to the question. You are like, you have just studied the theory, you are easily able to answer. The problem you face is in mixed questions. When I teach you questions from here and there, sometimes I'm picking this question, sometimes that question, then you get confused because I'm not teaching you theory. I want you to have that kind of practice. So that's why I'll be teaching you questions separately tomorrow, right? Okay? Yes, tell me. Is that clear? Is this page clear to everybody? Right? Take a screenshot of this page, everyone. Very, very important page this is, right? Okay? Now, let's see osmotic pressure. But for osmotic pressure, you must know three things here. Okay, osmotic pressure. Okay, I am drawing a basic diagram for you to make you understand everything here. Right, I am drawing a very basic diagram here to teach you, to make you understand everything here. First is that this is, let's say, a block. Okay, this is, let's say, a block. Right, in this you have semi-permeable membrane. In this you have semi-permeable membrane, maybe of, let's say, this color. This is a semi-permeable membrane that you will have here. Okay, now see what all can happen here. Now let's see what all can happen here. See this thing very, very carefully, everyone here, right? See what all can happen in this case. First thing is, let's say here you have only the solute, and here you have solute plus solution. Solute plus solvent, that is solution. Okay. Now let's see what is the definition of osmosis. The definition of osmosis is the spontaneous flow of, apne aap se the flow is happening by itself. Spontaneous means no external energy is required, of solvent particles. Solvent particles are moving. That means water particles will be moving if you take water as, because water is a universal solvent, from solvent side to solution. So solvent side is this side. Wait a minute. One thing, here you will have only solvent. Okay, one will be only solvent, one will be with solute. Okay, so firstly, what is osmosis? Osmosis, I'll draw it one by one. Osmosis is when you have solvent particles going from solvent side to solution side. That means this thing is called as osmosis. So I'll mention this here. This thing is called as osmosis, right? So osmosis can be written as solvent particles. Let's say this is 1 and this is 2. Okay. Okay. So solvent particles moving from solvent side to solution side, or solvent particle moving from this side is, you can say this is solvent side, you can say this is having more solute. Solvent particles moving from more concentration of solvent to less concentration of solvent. Movement will be only of solvent particles because solute particles are very large. They cannot penetrate through the semi-permeable membrane, right? More solvent to less solvent, or solvent particles can also move from this is the more solvent side or less solute. Solute is not here. Less solute side to more solute side, or you can say they are moving from less solution side where solution concentration is not there to more concentration of solution. Anything they can tell you to confuse you in the exam, right? So the movement of compartment 2 to compartment 1 is osmosis. Then what is osmosis? Osmotic pressure. The external pressure that must be applied on the solution to prevent the passage of solvent. That means now you will be applying some external pressure here, right? Let's say I am applying some external pressure on this side. Okay, this is the external pressure that I am applying. Now, when I say the movement is from compartment 2 to compartment 1, that is called as osmosis, right? When I say we have stopped the osmosis, no movement is there, no movement is there, right? So now in this case, what we have, there is no external pressure. That means external pressure is less than the osmotic pressure. Pi is the osmotic pressure, then osmosis is happening where external pressure is not that much high. When the external pressure becomes equals to osmotic pressure, then it will stop, osmosis will stop. But when the external pressure will be higher than osmotic pressure, then opposite movement will start taking place. Solvent will start moving from first to second compartment, and reverse osmosis will happen. That means in that case, this particular movement will take place in the RO, in the reverse osmosis. That is also used in desalination. Desalination means here let's say you have NaCl. Here let's say you have water. Here let's say you have NaCl. Let's say you have here NaCl. You have water here. You have here NaCl plus water. So in the case of reverse osmosis, the solvent particles, that means water, will move from first to second compartment. That means only NaCl will be left here and pure water will be formed here. That is desalination. So reverse osmosis is used in desalination. Okay. Acha, now see this. That is clear, right? Acha, now see this. Now we have three kind of things, that is reverse osmosis and all I have taught you. Now we have three kind of solutions. One is isotonic, then you have hypotonic, then hypertonic. Okay. So one is isotonic, then there is hypertonic, then you have hypotonic. Okay, so three kind of solutions are there. Just give me a second. Pi is the osmotic pressure, that is absolutely correct. Now, isotonic solutions are where pi 1 is equals to pi 2, both the solution have same osmotic pressure. Hypotonic solution is the one which has, let's say pi 1 is greater than pi 2. If I write it here, pi 1 is greater than pi 2. The one that has more osmotic pressure will be hypertonic. The one which has less osmotic pressure will be hypotonic. Hyper, someone who is very hyper and very high BP. Hyper, why getting so hyper, high BP? So from that you can remember this. Now, last is, from here I also want to teach you something very, very important that they can ask you in statement based questions. That is regarding the cell. Okay, shrink and all. So if you see, hypertonic solutions always shrink and hypertonic solutions swell up. I'll explain you why. Let's say this is your, let's say, I'll just write this here because that one I'm leaving for your formulas, right? Let's say you have a cell. Okay, this is the cell, this is the cell that you have. Okay, so I'll making two cells here. Let's say this is the cell and let's say this is the cell. Okay, now in the cell what you will have, this is our blood cell. Okay, this is our blood cell. So intravenous injections are, don't know if you have ever gone through intravenous injections. They are into your veins, right? That they go through your blood, right? So when you have intravenous injections, now someone is adding intravenous injections into your body. Now your blood is demanding 0.9% of NaCl. Blood needs 0.9% of NaCl. Let's say you have some hypertonic solution. This is hypotonic solution. So hypertonic solution means this will be less than. Now I'll just write here. Wait a minute. So hypertonic solution means this will be less than 0.1. So it will be less than 0.9% of NaCl. See, very simple thing, if it is less than 0.9, that means this is more 0.9. This is exactly 0.9% NaCl. This is less than 0.9%. Now tell me when something is less than 0.9%. Tell me. When it is less than 0.9%, it is less than 0.9%, what will happen? Its solute will be less. Means solvent will be more. Right? Now here solute is less because NaCl is less, solvent is more, and here that means if here solvent is more, here solvent is less. Now we know that solvent always move from solvent, that means it always move from more solvent to less solvent. So here more solvent, here less solvent. Wait a minute. No, I have written this for hypo. So I'll just write here, I'll not erase anything else, I'll just write here hypo. Okay, because I have written it for hypo. I'll just write here hypo and this is hyper. In the case of when you're adding hypotonic solution means which has less osmotic pressure. So less osmotic pressure injection you are applying in your veins, in your body. So here it is less, that means solute is less, that means solvent is more. That means here solvent is less, so it will go from more solvent to less solvent. So more solvent is here, less solvent is here. That means what will happen here? Solvent will move from more solvent to less. That means it will swell up. That means it will, because water is going inside, so it will swell up. Here what will happen? Here this is 0.9% of NaCl, right? Here what you have outside hypertonic. Hypertonic means more than 0.9%. That means solute is more here. That means solvent is less here. When solvent is less here, here solvent will be more. Here solvent will be more. So water will go from more to less. That means water will come out of the system. So the cell will shrink here. That is why a proper 0.9% NaCl should be added into your body, into your system. Okay. Tell me, is that clear? Is that clear, everyone? Okay. Simple thing I am saying, this is 0.9%. Body always needs 0.9%. In the injection that the nurse is adding into your body, that they are injecting into your body, that is less than 0.9. That means 0.9 means solute is less. That means solvent is more. That means here solvent is less. That means more solvent to less solvent it will always go. So it will go from here to here. So water will be added in the cell. So here swelling will happen. In this case, what will happen? More than 0.9 means solute is more, solvent is less. That means more to less it will go. Water will come out of the system. It is hypertonic. So out of the system means it will shrink here. Right? Okay. Okay, done. Okay, now let's see the last part of it, that is pi is equals to CRT. C is the molarity here. C is the molarity here, so it will be, you can write it like this. C is the molarity. Molarity. Okay, not molality. So it will be pi is equals to number of moles of solute by volume in liters RT. That is the formula. Okay, tell me. Done. Done, bacha. Clear. Everyone here. Done. Clear. Okay, I am teaching you in a very much detail so that you don't have to go through anything else, right? That's why I divided it into two parts, because like I could see that you guys are demanding more detail. Now see want Hoff factor. Want Hoff factor is I, that is observed colligative property divided by normal colligative property, right? I is also normal or actual molecular weight by observed molecular weight. Now there is a thing called abnormal and normal molecular mass. You know what will happen when something is being dissociated? We thought all are non-electrolytes, but NaCl, KCl, they get dissociated. You have acetic acid, that will form association and that will form dimer, right? So because of this, what will happen? Molecular mass, 1 mole mass will change here. That means if I say 1 mole of NaCl, if I assume that it is non-electrolyte, it is not getting dissolved into any kind of dissociation is not happening, I will say 6.022 into 10 raised to power 23 NaCl molecule, right? One NaCl molecule will have 85.5 multiplied by 6.022, that will become this much is the molecular mass. Okay, this will become my molecular weight, my molar mass. That is a normal molar mass for me, that I am not assuming any dissociation. In reality, dissociation is happening, right? In reality, 1 mole of NaCl is not 1 mole, because some particles are getting dissociated to Na positive and Cl negative as well, right? So what you will see here, because some particles are getting dissolved here, so maybe when you are counting, you are closing your eyes and you're picking 6.022 into 10 raised to 23 particle, maybe some particles are Na positive, some particles are Cl negative, some particles are NaCl molecule. That is why the molecular mass will be decreased in this case, because earlier you were adding all NaCl. Now you are picking Na, some you are picking Cl. Still particles should be 6.022 into 10 raised to power 23. So that's why abnormal mass is there. Same in case of association. In association, what will happen? You will think that A particles you need. This is, let's say, some A particle. You are thinking that, let's say this is CH3COOH, right? You are thinking 1 mole of this is needed. So you will take how much? 1 mole of CH3COH. But in reality, dimerization has happened. So what will happen when you're picking one molecule? In that one molecule, you will see A2. Because one molecule is not CH3COH. It is 2 into CH3COH because dimerization has happened. Right? So that is normal abnormal mass. So because of that normal abnormal mass, this is what you need to remember for your exam. Because of association, you will have, in the case of association, want Hoff factor will always be less than 1, and in dissociation, want Hoff factor will always be greater than 1. In this case, want Hoff factor is 1 plus alpha, that is degree of dissociation, plus alpha by n, and in this case 1 plus 1 minus alpha plus n alpha is the way to calculate want Hoff factor. And when you will see it in all the formulas, you will see that you have added want Hoff factor in all the formulas, right? So that is how it affects the colligative property, right? Now for the numerical purposes, we'll do more numericals in the tomorrow's class. For strong electrolyte, if there is no information about alpha, strong electrolyte is there is no information about how much degree of dissociation, you will take 100% dissociation. Then alpha is taken as 100%, that all the molecules have been dissociated. 100% dissociation or association, I is equal to the number of ions. That means I will be, whenever there is 100% dissociation, Van Hoff factor is equals to how many ions it is being dissociated. Like NaCl dissociates to 2 ions. So if 100% dissociation is there, I will also be 2. Okay. Then next is, if there is no information about solute, let's say you don't have no idea about solute, then you will take, in the question there is no information about solute, then you will take I equals to 1. If there is no information regarding solute is given to you, that means it is like 1 only. That means it is non-electrolyte only. For non-electrolyte like urea, you will also take it as 1. Okay, tell me, is that clear? Yes, everybody, is that clear? Done? Okay. That was the first chapter, that is solution chapter. Now let's move towards chemical kinetics. Let's see chemical kinetics. Yes, everybody. Let's move towards chemical kinetics. Okay. Let's see chemical kinetics. Right? It's a small chapter only, not a big chapter. Right? Not very much time it will take us, because most of the things are questions only, right? Most of the things are formulas only, so there is, concepts are very less, concepts are more in solution chapter, right? Yes, ma'am, it's 1:45, better start after lunch, as you choice. Do you want me to give you lunch break now? Tell me, do you want lunch break now? Yes. Because in 40 minutes we will not be able to complete this. It will take us 1 hour, maybe 1 hour 15 minutes, 20 minutes, like 90 minutes, 1.5 hour it can take us. Beta, do you understand English? Should I like write it here? PYQs tomorrow, PYQs tomorrow, PYQs tomorrow. Should I have a tattoo of PYQs tomorrow? Tell me. How many times do I have to tell you one thing? How many times? Yes. Very good, Dildar. Yes. Lunch break. Okay, cool. Okay, cool. So let's have lunch break then. Okay, so after lunch break, we'll do chemical kinetics. Right? We have enough time to do this, right? After lunch break, we'll do chemical kinetics, and then we will move towards firstly this thing. Yeah. Yeah. Yup. Acha, before lunch break, let me also see. I don't know if my lunch is also prepared or not. This chapter is small, completed fast. Ma'am, you said. So it's a mix, right? So let me just see. Wait a minute. Let me just see. Uh, you just bit of fast, so I will not do. Okay, it's a small chapter, but I could see that you guys need proper this. So 1 hour, so it will take me. I can complete it in 20 minutes as well. But you should also understand something, right? Okay, chalo. Chalo. I'll give you break then. Okay, I'll give you break. So I'll give you break till 2:20. Right? Okay, till 2:20 I'll give you break. Okay, it can go till 2:25. Okay, because I want to have my lunch properly, right? I also want you to have your lunch properly. So till 2:20 I'll give you break, and 2:25, and yes, okay. So after that we'll do chemical kinetics, right? Okay, chalo. So see you all after the break. Wait a minute, 2:20, 50, 60. This is 35 minutes. Oh my god, sorry. 2:20 p.m. That will work. 2:20 or 2:15? 2:15 p.m. will work. Okay? Because it's already 2:49. 1:49 it is. So I think 25 minutes is more than enough for your break, for your this, right? Okay, lunch. So 2:15 p.m. Okay, I'll see you all for chemical kinetics. Right? Yes. Yes, Dildar, I had honey made out of my own home. So it actually, you could see more energy today. So my actually throat is now fine. Yes. Chalo. So I'll see you all after lunch at 2:15 p.m. Hello. So yes, everyone, had your lunch. I'm just adding something here, right? By the time I add it here, right, you can just tell me what you had in lunch. Yes, what you guys had in lunch. Let me just add few things here. La 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 na 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 la 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 la. Wait a minute. This is what I wanted to add here. Then just give me a second, okay? Just give me a second, guys. Yes, I'm adding something very, very important for you guys, right? So I think this one, can I add all of them? Am I audible to all of you? Yes, ma'am. Okay, ma'am. How's the energy? How's the Josh? Why everyone is like, you're gonna cry just now? Why is it like that? Why it is like that, as if you're gonna cry just now? There's some extra things that I wanted to teach you, right? You might, like very rare chances that you will find this in your NCRT, right? So these are the things, and here two things, right? This one we have done, this one and this one, okay. To add this and then to add this. Okay, perfect. Now, yes, everyone, tell me, ready for the class? Let me just turn it into beautiful notes for you guys here. Yes, perfect. Where are others? I don't know. They are lost somewhere, right? I don't know where are they. Tell me. Chemical kinetics, yes, ma'am. Sports quota reservation in JEE, okay. What? Where are others? बिल्कुल सही श्रुति किया है और बहुत पछता रही हूँ, right? After coloring my hairs, never do that to your hair, right? Okay, but I can't see any energy over there. I will sleep after lunch, right? I can't see any energy over there, right? I can't see any energy. Oh my god, such a low energy class. Such a low energy class. Never I have taught JEE aspirants 10 days before with this much low energy. You're supposed to be very, very confident, right? Super, super, super high energy should be there, but I can't see anything. So I'll give you time, okay? I'll give you 2 minutes so that you can tell me if you're ready or not. Only then I'll start, okay? You can tell me if you're ready for the class, only then I'll start, okay? Fine? Yes? Still very less energy in the class. Where are you guys? Still very less energy. Anjali is ready. See, when I can see your names in the chat is not scrolling like this, automatically it means energy is very low. Energy should be so much high that I should not be able to see your names only. It should move so fast, right? The chat is not moving only. Yes. Still. Yes, now I can see. Oh, you couldn't have lunch. Oops. No worry, guys. I'll give you short break after chemical kinetics as well, but not that much long break. Yes. So let's start with chemical kinetics now, everyone. Let's start with chemical kinetics, right? Now, chemical kinetics, we deal with the rates here, right? So when I talk about rate, what exactly is rate, right? So to understand rate, let's understand these two things. There are two kinds of rates that you have, right? So I'll just divide it into one part here. There are two kinds of rates that you have. First kind of thing is when we talk about instantaneous rate. Instantaneous rate. Then we talk about average rate. Whenever we talk about instantaneous rate, we talk about d, small d, that means small change, and here we talk about delta, that means large change here. So now what you will see here, that rate is actually change in concentration divided by change in time. Okay. So here it is going to be, for example, this case I'll write R is equals to, whenever I write the reactants, okay, I'll just simply write, I'll not write even about this one. So in this case, you will always write d R by, or you can say not R, maybe dC by dt, right? In this case, you will write R is equals to delta C by delta T, because large change is happening here. Now further it is divided into two parts. One is rate of reaction, other is rate of appearance and disappearance. Rate of appearance and disappearance So based on this also they ask you the question. So let's talk about that. So when I talk about rate of reaction here, whenever we talk about rate of reaction, in that part, we'll say R is equals to, when I talk about the reactant side here, this is minus dA by dt, because reactant is getting disappeared. So you will apply minus here. So it is minus dA by dt, minus dB by dt. On the product side, you will always add positive here. So it will be plus dC by dt, and this will be equals to plus dd by dt, right? Okay. Now in the case of rate of reaction, you will always divide it with which thing? The stoichiometry is here. So it is 1 by A here. This will be 1 by A will be added here. Okay, so 1 by A will be added. Here 1 by B will be added. Here 1 by small c will be added. Here 1 by small d will be added. So in case of rate of reaction, you are always going to divide it with the stoichiometry. But when I talk about rate of appearance and disappearance, this is going to be R is equals to, if I talk about rate of disappearance of A, that is going to be only minus dA by dt. Rate of disappearance and appearance, you don't divide it with the stoichiometry. Rate of disappearance of B will be minus dB by dt. Rate of appearance of C will be plus dC by dt. And rate of appearance of D will be plus of dd by dt. So in the case of rate of appearance, disappearance, don't divide it with the stoichiometry. Don't divide it with the stoichiometry. You don't have to divide it with the stoichiometry. This is what you will see here, right? Okay, understood? Definitely mock test is good, beta, but you have only 10 days now. Also, if you're asking me, then when you will do that? Give the mock test on daily basis. Okay. So now let's talk about order and molecularity. But before order and molecularity, we must know what is rate law, right? So rate law, I'll explain you on the next page, right? Okay. Let's understand what is rate law. Rate law expression, right? Rate law states that, for example, I am talking about a reaction that is AA give rise to BB. In this case, if I talk about the definition of rate of reaction will be minus dA by dt, or you can just write it as minus 1 by A dA by dt is equals to plus of 1 by B dB by dt. This will be the rate from the definition. Now from rate law expression, what will be the rate? From rate law expression, what will be the rate here? Tell me everyone. From the rate law expression, what will be the rate? So the rate in the rate law expression is going to be, you will simply write it as rate is equals to rate constant. This is a rate constant that is defined in rate law expression. This is the reactant only. Reactant raised to power some order, that is n. Now n is the order of the reaction. Order of the reaction. Now for example, I am asking for this particular thing here, where I am saying, let's say there is AA plus BB give rise to CC, right? Now in this case, rate law will be applied. R is equals to K. This is A and this is B. Okay, so A and B will be your in the rate law expression. That means in the rate law expression, you only have the reactants raised to power, not the stoichiometries, but any number can be there, right? So this is B raised to power something. This is, let's say, X. This is, let's say, Y. So here in this case, X is the order with the respect to A and Y is the order with the respect to B. Okay. Now when I talk about this order of the reaction, we have two things here. That is, firstly I'll talk about elementary step, elementary reaction. Then we talk about complex reactions. There are two kinds of reactions here, elementary reactions and you have complex reactions. Elementary reactions, guys, are what? Elementary reactions are what? Elementary we talk about, they take place in only one step. This is a one-step reaction. In the one-step reaction, and these are multi-step reactions. Multi-step reaction, right? So here in the one-step reaction, you can say that when the reaction is one step, so we can say that if I write a reaction that is happening by A, 2A give rise to 3C, right? Or 3B, right? Or you can say 2A plus 3B give rise to 4C, okay? This is also the same reaction, that is 2A plus 3B give rise to 4C. Now here I am saying this reaction is happening in one step, that is elementary. So if whenever things are happening in elementary state, that means only one step is there. You can directly write the rate of the reaction and here reactant will be raised to power the stoichiometry. Because in the elementary reaction, one-step reaction, that is the rate determining step, and in that case, order will be defined by the stoichiometries, only in case of elementary. But when we talk about complex, in this case, rate will be defined by rate determining step, that is the slowest step. That is why rate will be equals to K, A raised to power, I don't know, X, B raised to power something Y. I don't know what is this X and Y. They may or may not be the stoichiometries. I don't know. Right? Okay. Is that clear? Right? Tell me. Done? Okay. So that was about order of the reaction in elementary and complex. Now what is the difference in order of the reaction? So order is experimental quantity, can be 0, negative or fraction, anything can be there. It can be 0, it can be negative, it can be in fraction, anything can be ordered. But molecularity is what? How many molecules are colliding to form that molecule, to have that reaction? How many molecules are colliding? That is called as molecularity. So we say it cannot be 0 or negative or fraction. Molecularity cannot be 1 also. Why it cannot be 1? Because one molecule cannot collide with itself, right? It has to have some other molecule. So molecularity can be 2 or maximum 3, because more than 3 molecules cannot collide because of the steric hindrance here. That is why molecularity is usually 2 or 3, maximum 3, right? So you can say order is applicable to both elementary and complex reactions. Order, we can see we can find the order in elementary as well as complex reactions. Both we can find the order of the reaction. But molecularity is applicable for elementary reactions only, which are taking place in one step. It has no meaning for complex reactions because so many steps are happening. That is why it has no meaning for complex reactions. Rate determining step determines the order of the reaction in complex reaction. Molecularity of the slowest step is same as the order of the overall reaction, right? Okay, so in this we are talking about the elementary step. In the elementary state, molecularity and order become same, right? Okay, now let's talk about three kinds of orders. We talk about order of the reaction 0, order of the reaction 1, order of the reaction 2. Now, these two are majorly in your syllabus, that is 0 order and first order reaction. Okay. But for this as well, we'll firstly study some general formulas of firstly rate constant here. Rate constant has a general formula that is mole per liter 1 minus n per second. Now in this case, when you put different values of n, you will get the rate constant here. If I put n is equals to 0, I will get mole per liter per second. If I put n is equals to 1, I will get per second. If I put n is equals to 2, I will get liter per mole per second. That is this. Okay. So that is a general formula that you should remember for the rate constant here. For different things you can answer. Then the next formula, general formula, is T half. That is always directly proportional to A naught, or you can, if I am taking initial concentration as, okay, let's take it as A naught only, A naught raised to power 1 minus N. Okay. So if I talk about 0 order reaction, if you put 0 here, T half is directly proportional to A naught. See, what is A naught and T half here? If you're asking that, then A naught is the initial concentration. T half is the time when 50% concentration is being consumed. Okay. Now, if I put 1 here, it will be T half is independent for first order reaction. If I put 2 here, it will be 1 by A naught. That means T half is inversely proportional to A naught. Right? Now, let's understand this thing here. But to understand this thing, I'll have to convert it into, wait a minute. I'll just convert it into A naught, right? Okay, so I'll just convert it into A naught, right? Because that's how we remember all the formulas. So in the next, when you will see my formulas, how I have written, you will see A naught only. So I don't want you to get confused, ma'am, what is R and what is A naught. Okay. Wait a minute. Okay. So if I see this here, this will be rate is equals to, for 0 order reaction, it is directly proportional to A raised to power 0. It is not dependent. This is K A raised to power 1. This will be K A raised to power 2. Right? That is the rate for 0 order, first order, second order. 0, 1 and 2 are the orders here. Now in this case, what you will have, this will be K is equals to A naught minus A by T. For first order reaction, it is K is equals to 2.33 by T log of A naught by AT, right? Then K is equals to, for second order reaction, K is equals to 1 by T 1 by AT minus A naught. Okay, that is a full-fledged 3 formulas that you must remember. Now, every single thing here is important. You should remember this. You should remember this. This formula is very important. This formula is extremely important for you. Right? Okay? Understood? Right? Now, let's talk about the next thing here, that is half-life. So, half-life, I told you that for zero order reaction, like T half, as I told you, is always directly proportional to A naught by A naught 1 minus N. That is the general formula, how it is dependent. So, you can write here A naught, here also, yes. So, you can say for zero order reaction, it is T half is equals to A naught by 2K, and here it is, wait a minute. Okay, so here for zero order reaction, T half is equals to A naught by 2K, and here T half is equals to 0.693 by K. Okay, that is for zero order reaction, that is for first order reaction. Both the formulas are equally important for you, right? Both the formulas are equally important for you, right? Done? This I will, yes. Okay, now let's move to the next one. These are the graphs. Okay, for zero order reaction and first order reaction, let's see the graphs here. Very simple they are. So if you see the graphs here, we'll see it from firstly zero order reaction. So in the zero order reaction, rate is directly proportional to, rate is equals to Ka raised to power 0. That means it is not dependent upon the concentration. So when rate and time, firstly when we will have rate and A, when rate and concentration, they are, we have a graph between it, then we say that this is, rate does not depend upon the concentration here, right? So we directly say it does not depend upon the concentration here, right? So you can directly write this over there. Then guys, next one is, wait a minute, I'll just draw it here only. So this is R is equals to, here I will write, this graph is based on R is equals to K raised to power 0. It is independent of A, that is why rate is a straight line parallel to x-axis, right? Now if I talk about this thing here, that what is the formula? It is A is equals to minus KT plus A naught, right? So that is the reason when you draw a graph between A naught minus AT and T, right? So the, if I write this here, this will be, I'm using this thing for the formulas only, so I can compare this for you, right? So if I talk about this graph here, if I write this, I know from this formula here, this is the formula. See, I'll do one thing here, guys, very simple. Why to make it so much complicated? I'll just write T half here for zero order reaction, that is A naught by 2K, and T half for first order reaction is 0.693, 0.6, because I believe less is the pages, easily you can remember things. More pages you will, you know, if on one page so many things are written, it is easy to understand and learn that thing, okay? So see, for the zero order reaction, we could see KT is equals to A naught minus AT, right? So I'll write KT is equals to A naught minus AT. So first thing is, when the graph is between, this is y-axis and this is x-axis. So I'll compare this, this is y and this is x. So next to x is always slope, that is m. And we will always compare this, y is equals to mx plus c. So when you compare this with mx plus c, y equals to mx plus c, c will tend to be 0, slope is equals to k, that is positive, and intercept is 0, that means it is starting from the origin. That is why this graph is starting from origin and it is positive, because it is a positive slope here. Okay. Now next is AT is equals to A naught minus KT. So if you have a graph where you have AT is equals to A naught, now what you have to, in the same formula, we have to variate the things. This is AT, you'll have to write it this way. This will become AT is equals to, this will become AT is equals to A naught minus KT. This will be the formula that you can variate like this also. Now when I say this is the y-axis and this is the x-axis, t is the x-axis, this is x. So this is plus m, this is c. So I can say c is A naught and slope is minus of k. So it is starting from A naught, this is A naught. And here the slope is negative, that is why it is a declining slope. Okay. Now next is this one. Next graph is this one, where what we can see, next graph guys, next graph is x and here it is x and kt. What is x? See, if I say A naught is the initial concentration, okay, if I say A naught is the initial concentration, AT is the final concentration, isn't it? If I say A naught is the initial concentration, AT is the final concentration, isn't it? What is X? X is the molecule which are being consumed, So how much it will be consumed? A naught minus AT. The initial concentration minus final concentration. Let's say you have 10 balls. Out of that, let's say you have 10 chocolates. Out of that, you have used 2 chocolates. Remaining will be 8 now. So if you have 10 and remaining is 8, how much is consumed? That is 2. So it is A naught minus AT. So that is X. So you can say, if I say A naught minus AT is equals to KT, A naught minus AT is X only, so X is equals to KT. If I say this X is nothing but this is Y axis, so comparing this with Y is equals to mx plus C, intercept is 0 and slope is K. So I can say that is why it is starting from 0 here and the slope is positive here, right? Okay, now let's see the last one here. Don't cram anything because there is no need to cram, right? Okay, dig in the R and whatever you want to take, you can take. I have a habit of taking E and A naught. If you have a habit of taking R naught and R, take that. It is just a representation. What is alpha? Alpha is the degree of dissociation. What is the formula of degree of dissociation? Yes, degree of dissociation. Number of moles dissociated by initial moles. How many moles are dissociated? X moles are being consumed here. Initial moles are A naught, right? And what is X? X is nothing but it is A naught minus AT. So you have to take A naught minus AT by A naught. So that how you can take simple thing. So we can say alpha is equal, what is A naught minus AT? A naught minus AT. A naught minus AT is nothing but it is KT. So you can say alpha is equals to KT by A naught, right? Now you can see alpha is the y-axis, this is the x-axis. So when you compare this, you can also write it as alpha is equals to K by A naught into T. Now you compare this, y is equals to mx plus c. Intercept is 0, slope will become K by A naught. So slope is positive, it is, and here intercept is 0, that is why it is going from the initial point, that is origin, right? Okay, tell me. Is that clear to everybody or not? Is that clear? Everyone here, is that clear to everyone or not? Tell me. अंजलि, हरीश, पॉल, क्या हुआ? शो का whatever, right? Okay. Perfect. I'll start at 12 only, okay? Yes. Tell me. Done? Done, done, done. Shall I move ahead now? Shall I move ahead now? Yes. Perfect. Now, these graphs will be little more tiring for you. Otherwise, so there is not much in chemical kinetics. These graphs are going to take time. This graph. Okay, so what I'll do, I'll separate this into two parts. Okay, I'll just divide it into two parts because I need something to write as well. So what I'll do here, let's have this graph will not have here. Okay, this graph will not have here. These two graphs we can have here. Okay, first you will do graph of ln, then we'll do graph of log. Okay, perfect. Then we will do graph of log. Yes. Let's see this, everyone. I think two graphs are missing here. No, they are not missing. Okay, perfect. This one, and here I'll do log graph. Okay, because I need page also to write down things that I want to tell you. Okay, perfect. Now tell me, you should only remember the formula here. Everything else is quite simple. And so many times they have asked you this in your JEE. Okay. So one by one we'll do these graphs. Let's discuss about them. Let's discuss about them. So if you talk about this graph firstly, first graph is dependent upon R is equals to, we know that R is equals to Ka. That is why rate and concentration, you will say it is directly proportional when you compare this with y is equals to mx plus c, intercept is 0 and the slope is k, that is positive. So slope is k and intercept is 0. Right. Now next is we have ln, right? So we know that ln of 80 is equals to, you can say, you can also write it as ln of a naught minus ln of 80 is equals to kt. This is the formula that you have here, isn't it? This is the formula you have. Wait a minute. This formula is actually also written like this. Okay, this formula, when you convert it into log and all, then it became that. Actually, this is the formula, ln of a naught minus ln of 80 is equals to kt. Now, if I want to have ln of 80 as the y-axis, what I'll do? I'll keep this here. I'll say ln of 80 is equals to ln of a naught minus kt. This is the formula that I'll have, right? Now I will compare this formula with y is equals to, this is mx and this is c. So c will become ln of a naught and slope will become minus of k. That is why it is starting from ln of a naught and slope is negative, that is minus of k, right? Now when I say the y-axis has to be ln of a naught by 80, then what I'll do? We know that for 80 to be in the upper side, we should convert it into ln of 80 minus ln of a naught is equals to minus of kt. Now this will be converted to ln of 80 by a naught by applying properties of log. Now if you see, this is y is equals to, this is mx plus c. Intercept, there is no intercept. Slope is minus of k. That means here the graph is actually wrong. So this is, I have made it for ln of 80 by a naught. Okay, we can also do that. We can make a graph on, ln of, this also graph can be asked to you, na? The graph can also, that they can ask you ln of 80 by a naught, right? That will be equals to, it will have intercept as 0, intercept will be 0, but the slope will be negative, that is minus of k, right? Here the graph is between ln of 80 a naught and t. Anything they can ask you. Now let's see, they have asked you the graph of this one. So I will just do this graph here, right? This graph here. This is so very simple, right? This is very simple. So if you see, here they are saying that you have ln of a naught, ln of a naught minus ln of 80 is equals to kt. You can convert it into ln of a naught by 80 is equals to kt. Then you compare this with y is equals to mx plus c. C becomes 0 and slope becomes k here, right? So here it is starting from 0 and the slope is positive here. This is what you will have here. Tell me guys, is that clear? Is that clear? Tell me, is that clear? Done? That was about these graphs. Now we will talk about another thing, that is log graphs. So first is the graph of log of a naught. Firstly, I'll talk about log of, when I convert this into, this graph is actually ln of a naught minus ln of 80 is equals to kt. Ln of a naught minus ln of 80 is equals to kt. When you convert it into log, this will become log of a naught minus log of 80 is equals to kt by 2.303. 2.303 will be multiplied, that will shift here. Then if they ask me to draw a graph, now so many graphs they can ask you here. Okay, let's talk about that. This now, this though, I'll just copy this here. Yeah. So many graphs they can ask you here. First graph is, they can ask you the graph of, the graph between, let me see, even I don't know whether it will be positive or negative, so I'm just drawing it like this. So first thing they can ask you graph of, let's say this one, let's say they ask you graph of log of 80 minus log of a naught, that is minus kt by 2.303. Now when I compare this, if I compare this, this is y, if I say this is y is equals to mx plus c, then slope will become minus k by 2.303 and intercept will become 0 here. So if I say the graph is between log of 80 minus log of a naught, right? In that case, or you can say the graph, it can also be written like this. This can also be written like log of 80 by a naught is equals to minus k by 2.303 into t. So these two graphs are same. Y is equals to mx plus c. Again, intercept is 0 here. And the slope is minus of k by 2.303. So whether this is given or this is given, in that case, you will have intercept will be 0 and the slope will be negative, that is minus k by 2.303. This is your JEE question, PYQ only. This is PYQ only that they have asked, right? Now, next thing is, when I talk about, let's say they are now talking about ln of a naught, right? Now they are, let's say, talking about ln of a naught by 80. So a naught by 80, you will say log of a naught by 80 is equals to kt, or you can just write it like this, k by 2.303. This is k by 2.303, this is t. So you can compare this as y is equals to mx plus c, where c is 0, slope is equals to this. So it is starting from 0 and slope is positive, right? Now another graph that they can ask you here is, when you take log of 80 as y, so if you take log of 80 as y, log of 80 is equals to minus of k by 2.303 into t, I'm comparing this only, plus log of a naught. So when you compare this with y is equals to mx plus c becomes this and slope become positive. So slope is, wait a minute, slope is negative. It is starting from log of a naught and it is dropping, slope is negative here. Okay, tell me. Tell me, is that clear? I could like, chalo. So much with so much patience and everything I am teaching you, but chalo, as you wish. Now let's see the next one. Let's see this. 80 and A naught they are saying, na? Wait a minute, there was also one more graph. It is here. Okay. So I'll just put it here only, right? Now when I talk about AT and A naught, so the graph of AT and T. So if I have to convert it into AT and T, how will I do that? Let's talk about that. Okay, how will I do that? Let's talk about that. So you have this particular thing here and you need to convert it into AT and T. So how will you do that? See, log of A naught and this. You want to have AT here, so what we will have here? We can have ln of AT minus ln of A naught is equals to minus of KT, right? Then we can say this is ln of AT by A naught is equals to minus of KT. Then taking exponential on both sides, this will become AT by A naught is equals to e raised to power minus of KT. So AT will be equals to A naught e raised to power minus of KT, and this is the formula that you have here. This is the formula that we have written here. Okay. Now see how am I writing that this means it is decreasing. Understand that. If I say if I say time is increasing, in this case time is increasing, right? If I say time is increasing, that means minus of time will be decreasing, opposite of that will decrease. That means minus of KT will decrease. If minus of KT is decreasing, that means e raised to power minus of KT will also decrease. And that is the reason here you can see that there is exponentially decreasing graph here. So what you can do here, you can just put the graph here, right? You can just put the graph here. That will be, wait a minute, that will be this one. Okay, because I want to take all the graphs here and T. So that is why it is decreasing here exponentially. Okay. Now if I say I want to have a graph between x and T. What is x? Tell me what is x here, everyone. What is x? Now if I talk about x here, x is nothing but it is A naught minus AT, right? So A naught minus AT, what is A naught? AT is A naught minus e raised to power minus KT. If you take A naught common here, this will become 1 minus e raised to power minus KT. So that means you can say x equals to A naught 1 minus e raised to power minus KT. So now same thing will be applied here. If I say time is increasing, minus KT will decrease, that means e raised to power minus KT will decrease. That means 1 minus e raised to power minus KT will increase because the subtraction factor is decreasing. So overall subtraction will, that means 10 minus 3 is 7. 10 minus 5 is 5. If this factor is decreasing, this factor is increasing, no? Same thing we are talking here, right? So we can say the graph of, now if I draw the graph of, which one? X by t. That is going to be a increasing graph. As you can see, this is going to be a increasing graph here, right? This one is a increasing graph. So we can say this is a increasing graph. Exponentially increment is happening here. Now the last graph that we are discussing here is between alpha. Now what is alpha? What is alpha, everyone? Tell me, what is alpha? Very simple. If I talk about alpha here, alpha will be what? Firstly, though, I have to take this graph. Okay, chalo, we'll see what we can do about it. Right, chalo. What I can do, Et is equals to A naught e raised to, I am just directly writing it here, okay? Et is equals to, this is, you can say ln of AT by A naught is equals to minus of KT. So AT is equals to A naught e raised to power minus KT. That is the formula. Now we are talking about that this is a formula, but we want to talk about something else, right? We want to talk about alpha. Alpha is nothing but dissociation by initial. X is nothing but A naught minus AT by A naught, right? That means this will be equals to 1 minus AT by A naught, right? Or you can just simply write here A naught by AT. This we have written as A naught 1 minus e raised to power minus KT by A naught. So alpha will become 1 minus e raised to power minus KT. That is why the graph of this alpha and t will also be the same. This is alpha and this is t. This will also be the increasing graph. Because t is increasing, 1 minus e raised to power minus kt is also increasing, which is directly, so that is why this will also increase. Right? Tell me, is that clear? Right? Done? Yes. Now let's move ahead. That is done. Now let's see some other important things here, right? First is that what we could see that in the zero order reaction and first order reaction, two things were there. In the zero order reaction, if you have initial concentration A naught, after T half, the concentration will be half of it. After another T half, concentration will be 0. That means in zero order reaction, after 2 halves, the reaction is completed, right? So after 2 halves, the reaction will be completed in a zero order reaction, right? So you can state this here. But what about a first order reaction? What about a first order reaction? In first order reaction, these things will not happen. If you take A naught initially, after one T half, it will be A naught by 2. After another T half, it will be A naught by 4. After another T half, it will be A naught by 8. After another T half, it is half, half, half. That means it is never undergoing end. The completion is never happening, right? So after every other T half, it can never undergo. The first order reaction will never undergo completion, right? So it will always be half of what is here. Half of this is this. This is half of this. This is half of this. This is half of this, and so on will happen here. It will never undergo any completion, right? That is why there are some very, very important relations, right, of T in the percentage. That means 2T half is equals to 2T half means 75% of it is completed. 3T half means 82.5% of it is completed. 4T halves means 88.75% is completed, right? Then we say T 90% is 3.33 T half. Then also ask T 99% is 6.67 T half. They can directly ask you this in the exam. So these are shortcuts that you should remember, right? Then they can ask you T 90% is 2 into T 90%. T 99.9% is 10 of T half. Okay, so these are all the important things that you must remember, right? And one more thing about applying the first order reaction. See, if let's say they don't give you, they don't give you initial concentration. Initial concentration is not given. Then what you will do? Then you will say, if it is given in fraction, if it is given in fraction, you will take A naught as 1, and if it is given in percentage, if it is given in percentage, in case of percentage they are saying 75%, 22%, 30% is consumed, then you will take A naught as 100, right? Okay, tell me. Done? So now we have pseudo first order reaction. What is pseudo first order reaction? It says that reaction in which kinetics of reaction is studied by decreased order. That means this, we can say pseudo first order reaction is known as pseudo order reaction. It happens when? Now with decreased order we are studying the reaction. So that means it looks like it is first order reaction, but in reality it is not a first order reaction. In reality it will depend on this thing and this thing both. But why we are not considering water here? Because water is in excess. That is why we are only considering that it is dependent upon only the ether, ester. But in reality, it is dependent upon water also. But we are not considering water. That is why it is called as pseudo first order. In reality, it is supposed to be of higher order reaction. But we are considering it as first order reaction. Cases are either any of the reactant is in excess, like here water is in excess, that is why we are not contributing water into the rate law expression, or you can see in the inversion of sugar as well, you will consider this water will not be considered here. Wait a minute, this will be not be considered here. Yes, by mistake it is written here, it should be here. Sucrose and fructose are formed here, right? So it is dependent only on the sucrose, it does not depend upon water in the inversion of sugar, right? Okay, yes. Then next is temperature dependence. Now in temperature dependence, what we will see, I'll just tell you simply here a trick by me, right? See, now we say that for a chemical reaction with rise in temperature by 10 degrees Celsius, the rate constant is nearly doubled, right? So whenever they give you, let's say 90 degrees Celsius to 120 degrees Celsius, 120 degrees Celsius, how much rate is increased? They are asking you this. So how will you understand this? How you will answer this? See. First you will say M is equals to what? M is the temperature, new temperature minus old temperature divided by 10. This is just a trick. M is just any number, right? You will get the value of M here, and the new rate constant, or you can say new rate is equals to 2 raised to power m times the old rate, or new rate constant is equals to 2 raised to power m times the old rate constant, right? So that means if I say this thing here, m is equals to 120 minus 90 divided by 10, that is 3. So new rate is equals to 2 raised to power 3 times old rate. That means rate is, or rate constant is increased by 8 times. Better will be to write rate constant is increased by 8 times. Okay, this is a trick here that you can solve your questions very easily, right? Okay, tell me everyone, is that clear? Done? Now let's talk about Arrhenius equation. And before Arrhenius equation, okay, so firstly let's talk about Arrhenius equation only. Arrhenius equation is when we say that K is equals to A e raised per minus EA by RT. R is gas constant, this is temperature in Kelvin, this is activation energy, A is Arrhenius constant. Arrhenius constant is also known as frequency factor or pre-exponential factor or constant specific to a particular. This is a constant that is specific to a particular reaction, right? Now we say that when I talk about Arrhenius equation, when I talk about activation energy, I am talking about this thing here. That means if I say there is potential energy and this is the reactant, this is the product. We say that whenever reactant is getting converted to product, it is passing through an intermediate state that is called as activated complex, which has its own activation energy, and this reactant has to pass this activation energy barrier to get converted to products. If this reactant is not able to get this much amount of energy, it will not be converted into the products. Okay, now you can also tell whether this is endothermic or exothermic reaction. As the energy of reactant, the enthalpy of reactant is higher than the product, right? We know delta H is equals to product minus reactant, product minus reactant. So whenever enthalpy of reactant is higher, that becomes a exothermic reaction. So this actually is a exothermic reaction. Okay, now when we say effect of catalyst on the activation energy, then when we say that a catalyst is added, a positive catalyst is added, the positive catalyst will lower down the activation energy so that you don't have to do that much work, right? So earlier this reactant has to match this level, now it only has to match this level. So because of activation energy, the reaction tends to move in a faster rate. Okay, now next is this thing, that is now I'll talk about this thing here, how to convert it into that. Okay, I'll just talk about this, is very important, that is Arrhenius equation. So K is equals to A e raised per minus EA by RT. So if I take log, it will become ln of K is equals to ln of A minus EA by RT. When I convert it into log, it will become log of K is equals to log of A minus EA by 2.303 R, and this is T, right? Now you can also make the graph here, right? If you take a graph of ln of K and ln of 1 by T, this becomes Y, this becomes Y is equals to, this becomes M, this becomes X, and this becomes C. Okay, so intercept is ln of A and slope is minus EA by R, and this is what you will have. Okay, so I can also write it here. Right, this graph now, wait a minute. Why to use this much space, no? When we can use less space. See, two graphs are possible, right? Two graphs they give you. One graph is between ln, then the next graph is between log. So one graph is when I say I am talking about ln of K and 1 by T. In that case, intercept is ln of A naught and it is a negative slope, that is minus EA by R is the slope here, right? But when I talk about that I am using this one thing here, that is log of K and this is 1 by T, in that case this becomes the intercept, that is log of A, and slope becomes minus EA by 2.303 R. Okay, Understood? Tell me. Done? Now let's talk about when you solve all of this, you get a formula. This is for numerical purpose we use, where K1 and K2, it is the rate constant for temperature T2 and K1 is the rate constant for temperature T1. And you get log of K2 by K1 is equals to E naught 2.303 R T2 minus T1 by T1 into T2. This is another important formula, right? Okay, everybody, tell me. Done? Now, next is this thing that we have studied, right? But you have only studied the numerical purpose of it. But in reality, what was happening? Let's talk about that. So in reality, what was happening here in the case of when you increase the temperature, why the rate was getting doubled? Reason is here. So initially, when you say the temperature was T, everyone is like, this is my activation energy. No, 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 no. Whenever the temperature was T, in that case, this is a fraction of molecules and this is the kinetic energy. Now let's say this is without your teacher, without someone who is your mentor. You are like, okay, I'll do solution today. You are sitting for 3 hours and you are studying solution only, right? You are studying chemical kinetics for 3-4 hours only, right? But with me, you are doing it fast, in detail, right? So when you don't have teacher, so what is happening? This is a maximum fraction of students are maybe getting 70% marks in their exam, only 70%. Now with the teacher, maximum students, this is a maximum students, maximum fraction of students are getting 99.9 percentile in the exam, because this is with the help of teachers, right? So that means when the teacher has entered, your accuracy has increased, right? Same thing is happening here. With lower temperature, less molecules were having activation energy, having energy more than activation energy. Because to get converted to products, you need to have activation energy, right? So when the temperature is T, very rare molecules had like more energy as compared to activation energy. Very rare students were able to pass through this. Let's say this is the activation energy. Very rare students were toppers. This is the, if this is the activation energy, this is the initial goal. Only these many students were the toppers. That means only these many students were able to clear JEE. But when the teacher has arrived in your class, now more students, after activation energy, you have more number of students, nearly double students you have. This is what we want to say, that whenever temperature is increased, more molecules will have energy more than activation energy. That is why rate will double, right? Okay, understood? Tell me. Last is collision theory. Collision theory explains 3 things here, right? 3 things. It says that if I talk about that reactants will be converted to products, it depends upon 3 things here. That you will get to know from this formula here. He said that first thing is, wait a minute. Don't remember this formula, right? Just remember, don't remember this formula. Okay? This formula you remember. This formula is your main important thing here. So we are saying it depends upon 3 things here. First is probability. Probability means first thing is the probability steric factor. That means first thing is, okay, let's talk about one by one. It says that rate depends, that the reactant will be converted to product depends upon 3 things. First thing is collision frequency. That is ZAB. That how many collisions are happening. Are there more collision? If more collisions are there, more rate will be there, right? If collisions are less, rate will be less. Then how many collisions are happening with good orientation. That means orientation is proper, right? Their orientation is proper to make the products, right? Then third factor is activation energy. If there is energy is higher than activation energy, only then they can make the product. So they say it depends upon three things: probability factor, collision frequency, and activation energy, right? Okay. Done. Tell me. Clear? Tell me, everyone. Done? Beta, are you even respecting the teacher who is teaching? है ना? The teacher who is teaching, you're not coming to their class, right? I'm just stupid here who is standing here, right? So you're not even respecting the teacher who is teaching. Literally 18 live watching on a marathon. I've never been in that stage. Trust me. Worst thing that I'm experiencing right now. If you don't want me to take classes, why to say I will, ma'am, marathon, ma'am, we will be there? Why to have all that kitch pitch? I'm not doing the class tomorrow. You do it yourself. I'll send you the PDF, do the PYQs yourself. No matter how much we teach you, you're always. That's why Namrata ma'am is not here. That's why Sher sir is not taking the classes, because you guys don't. It doesn't matter to you. Hardly does matter. But how does it matter? You will have tons of teacher out there, isn't it? Oh, ma'am, we have so many marathons going on, ma'am. Doesn't matter. That's the thing that happens, when everything is in excess. When free education was, when free education was provided in very limited way, then there was respect for teachers, because you know that, okay, this is something we are getting for free, we should respect this. But now you guys don't respect it at all. Like, okay, whatever you are saying, we have tons of marathons going on, right? So we'll see whosoever is like teaching in a faster pace, whosoever is giving fake promises, right? That do these five questions and you will like score very good. Then like, okay, five questions I can do. Ma'am is teaching in detail. Oh, I don't want to teach anything in detail. Who will, you know? Hmm. I am not even discussed. Don't worry. Even skipped this. I worked for so long. Many other championships and opportunity for G's. That's so sweet, Dildar. That's so sweet. That actually makes me happy, right? No, actually, these things makes me question why I'm not teaching in offline. Why I'm teaching here? Why? That, because the whole purpose of doing this was, that I can reach to more students. More than 26 students I can teach in an offline class. Like 100 students I can teach, right? So 100 nahi to 50 60 students easily, that I have taught also. So I'm like, the goal was not this. Online, to be online, goal was definitely not this. Goal was to go to more audience, but I think I should be teaching in offline only. At least I'll have more students and their responses, isn't it? I think you guys will be my last batch online. Sometimes I have this feeling very strong. Then you will find me on in the like YouTube old videos. You'll see, Diksha Ma'am, where she is now. So yes. Perfect, Anjali. Without your presence, we can do it. We're always listening to you. Without your presence, we can do it. Yes. Many students preparing for CS boards. CS boards. CS boards. Okay. Okay. Oh, I know you guys are getting knowledge, but that irritates me so much. I'm like, if you're not prepared for marathons, then why I'm standing here like, okay, chalo. Now, shall we do redox reactions? Shall we start with redox reactions? Tell me. Now, redox reactions. Shall we start? Done, done, done. Thank you, Nishant. Even I sometimes feel I deserve better. Like, not you guys are the best. Sometimes I feel that, sometimes I think that, what am I doing wrong? Am I just focusing on content? I'm not doing any, like, what am I doing wrong that the students are not coming? That I sometimes I be like, okay, content is fine only, right? Like everything is good, I am hard working, then what is the problem? Then I realized one thing about students. I feel that students, today's generation, tell me if you agree with me, this is what I have concluded. So what I've I have seen really good teachers on YouTube having 2 to 3 live watching as well. The views are like 100 or 200 views as well, because their channel is like maybe not from a very big brand or anything, right? So I have literally seen so many teachers which are very, even MS Chauhan sir, right? He has written a book. You go and see his like views on his videos will be very less as compared to other teachers, other chemistry teachers, right? Then I think such a scholar person who has written a book, his videos of organic chemistry you will find on YouTube, but you will not see like many views there or live watching there. I feel like what exactly is that students need? That I got that you need proper energy from the teacher, that is also there. You need good content, that is also there. So that makes me question that what exactly it takes to be a good YouTube teacher, right? So I've been here in this industry. I have taught like maximum, I think 3,000 live watching I have taught maximum, right? Not more than that I have gone. So that was also an era. I was teaching same only. Now this is also I am teaching same. In fact, now I'm teaching even better, because more you learn as a teacher every single day. I learn something new about you guys, and I try to implicate that in my class, right? So I don't know. Yeah, I don't know whether English medium or not. It's not about me. I just randomly think about these things. There are so many teachers out there. They are very good teachers. I've seen some really good biology teachers as well. They don't get views. Right? So I really question that, is it like when someone is getting famous, someone is getting like views in live watching, students go there only where the live watching is more, right? This is what I have like understood there, because very rare students are who are on YouTube, they are actually passionate about studying something. Very rare students, very small chunk is there. Most of the students are there, either in the end they just want to score good in last 2 3 days. Last 10 days, ma'am, how to crack NEET. Last 10 days, ma'am, how to crack JEE. It's not possible only. So, how can I tell you that this is possible? Right? As a teacher who has also taught offline students, I can't say that you can crack NEET or JEE in just 10 days. That's not possible. Right? But I have seen videos on that. I have also made a short. You will see, don't NEET English, you will see a short. I have made a funny short on how to crack NEET in 30 days. And there are around 1 million views on that short right now. And there are so many students who are saying, you're doing motivating us. How can you say this? I'm like, how can you crack without even zero knowledge? How can you crack NEET in 30 days? That's not possible. Same for JEE, right? So I think either I'm just too blunt. I don't give fake promises to students that they want to hear. I just tell them the reality. Yeah. Yes. Is it possible to get NEET? Hmm. Okay. Chalo. Now let's see. Huh. My subject is very good, huh? Huh. I love chemistry and I know my subject is best. Chalo. Now let's see redox reactions, right? See, it's a very simple rule of life, right? If X or Y person has like 1,000 live watching or 2,000 live watching on their video, when they will see that this teacher is teaching and it's only 26 students watching and there you have 2,000 live watching, students are attracted towards seeing where there is more live watching and then it exponentially grows, right? So that is the maths, right? So I know what is exactly happening there, but I feel like, okay, those students who are my students who are studying from me, right, why they are not joining the class, that makes me very sad. That is like, you tell that ma'am take this class, then I take because of you. I was not even thinking about taking theory. You said that ma'am we want theory as well on the Telegram channel. That's why I thought of taking theory as well. Okay, only for you guys. I was not planning to take theory because I have done it in Jan attempt as well. I thought, okay, if they're asking, let's do, right? I knew that on theory, if I talk about a YouTube teacher perspective, I knew that if I have done it in Jan, there will not be views on it. But still, I did it because I know, okay, some students are asking for it, they need it, let's do that, right? So, yep. Don't worry, we'll do that. Chemistry before used to like chemistry more than now I love chemistry. Awesome, awesome. Chalo. Chalo, now let's see, okay? Redox reactions, it's a very, very small topic, very, very small chapter. Now in redox reaction, majorly what we will be focusing on, let's talk about that. Okay, firstly, I'll tell you some general points about redox reactions. Acha, tell me one thing. Redox, what do you mean by redox? Red means what? RED, that means reduction. And this means oxidation. So when the reduction and oxidation are occurring simultaneously, that is called as redox reactions, okay? So see, when there is reduction, reduction is happening when there is gain of electrons, and here oxidation number decreases, right? Now what is happening in case of oxidation? Loss of electron is happening, and here oxidation number is increasing. Oxidation number increases here, that is redox reaction, okay? This is the starting of redox, right? Then I'll not cover the full redox, I'll cover only the important points of it. I'll be very clear on that, right? So if you see this here, the oxidation number of any uncombined element that is in its pure state, like sodium, magnesium, sodium, magnesium, then you have helium, argon, potassium. These are uncombined state. They are not making any molecule here. In that case, their oxidation number is going to be 0. Then the oxidation number of a monatomic ion, if there is an ion that has only one atom, that will be the charge on it. Like you have Cl negative, that is monatomic, only one atom, it will be equal to the charge on it. The more electronegative element in a binary compound is assigned the number equal to charge. They are saying The more electronegative element in a binary compound, like you have NaCl. This is more electronegative, this will be -1, this will be +1. Right? Binary compound is assigned number equal to the charge it would have if it was a ion. For example, MgCl2. Now, if Mg was an ion, it would have the charge Mg2 positive. If Cl was an ion, it would have a charge Cl negative. That is why these are the charges on it. Cl has negative and Mg has 2 positive. Oxidation number of fluorine, which is the most electronegative element, is always going to be -1 no matter what, because there is no other electronegative element that is present. It is the most electronegative element, right? Next is oxygen can have -2 as well, unless it is combined with fluorine. Because fluorine is more electronegative, then it will have +2 or +1, in which it will have +1 or +2, right? Or it is in the peroxide state, it will have -1. Okay, I'll just tell you this here. This bacha means, this means H2O, in the case of H2O, it will be -2. In the case of peroxide, like H2O2, it will be -1. In +1, it will be O2F2. In case of O2F2, it will be -1, +1, oxygen will be +1. In case of OF2, it will be +2, right? So these are the things that you will have here, right? Then the next one is, next rule is, you will have hydrogen oxidation number is most of the compounds under +1. That means hydrogen in most of the cases will have +1, unless and until it is combined with some less electronegative element. If it is combined with a metal, in which case it will be -1. That means, for example, LiH. Here lithium will have +1 and hydrogen will have -1, because hydrogen is now more electronegative. Right? In the compound, the elements of groups 1 and 2, group 1 will always have +1, group 2 will always have +2, and group 3 will have +3. Okay, as well as aluminium have oxidation number of +3. Okay, aluminium will have oxidation state of +3 here. That is fixed. Sum of the oxidation number of all the atom in the neutral is going to be 0. That's how we calculate the oxidation number. We have seen it in coordination chemistry as well. The sum of oxidation number of all the atoms in polyatomic ion is equal to its charge. If it's a charge like H2PO4 negative, then sum of oxidation state of all of them will be equals to -1. Right? Okay. Now let's see this thing here. Now let's see this thing here. If you talk about this thing here, it will be H2O. In the case of H2O, this is the formula. This is oxygen. Wait a minute. This is going to be oxygen. This is H. This is H. H is +1. H is +1 because it is less electronegative. This is here. It will be -1. -1. It corresponds to total -2 charge. Okay. Now, if I talk about H2O2, this is +1. Hydrogen. This is +1. So corresponding to this, it will be -1. Corresponding to this, it will be 0 here. Corresponding to this, it will be 0. Corresponding to this, it will be -1. So answer will be -1 here, -1 here. That is why in peroxide it has -1. In O2F2, this is -1. This is more electronegative. More electronegative. This is less. This is less. So it has +1, +1. In this case, it is -1, -1. Corresponding to this, it will have +1. Corresponding to this, +1. So total it is +2. Right? Next is this one. In this case, you have Br, Br, Br. Wait a minute. I'll just essay, so it will be difficult for me to teach you that what exactly we are doing here. So what I will do, wait a minute. So I will have this Br, this Br and this Br. Double bond O, it was this only, na? Double bond O, 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 right? Double bond O, double bond O, and double bond O. Now, in this case, how you will study, let's see that. Boron, that is going to be less electronegative as compared to this oxygen. So oxygen will be 2 bonds means -2. So it will be -2 here, it will be -2 here, it will be -2 here. 2 bonds means +2, this is also +2, this is also +2. With bromine, no bond. This is -2, this will be +2, -2, so this will be +2. This is -2, -2, -2, +2, +2, +2. So if you see, on this bromine you have 1, 2, 3, 4, 5, 6 plus 6 charge. On this bromine you have +4 charge. On this bromine you have +6 charge. So total it will be, total how much charge you have, average will be 6, 10, this is 16, 6 plus 4 plus 6 divided by 3, that is 16 by 3, because total it is 3 bromine atoms, and here it is +6, here it is +4, here it is +6. Okay? Now, next is, if I talk about this butterfly structure here, if I talk about this butterfly structure here, right? In this butterfly structure, what is the charge that we are discussing here? Let's see. This is Cr, this is Cr double bond O, this is 1, 2, 3, 1, 2, 3. This we have also discussed in coordination compound, okay? Double bond means -2, this is +2, this is -1, this is +1, this is -1, this is +1, this is -1, this is +1, this is -1, this is +1. So chromium has 2, 3, 4, 5, 6. Chromium has total +6 charge here. 4 oxygen has -1 and 1 oxygen has -2 charge. Okay? Next is similarly you have other things here, you can see it yourself as well, right? I am giving you this for homework, you can go through this yourself as well, right? Now next is 2 methods by which you can balance it. Okay, tell me. Two methods by which you can balance this. Let's talk about it. So I will teach you only one method here, right? Tell me which method you want me to teach. Because in this balancing, it hardly matters that which method you are using. You should know how to balance, right? So what I feel is half reaction method is easy, right? So it is surely your choice how you want to do it. I'll teach half reaction method. Okay, so firstly what we will do, half reaction method, identify atoms undergoing oxidation and reduction, separate them into 2 halves, balance all atoms except for hydrogen and oxygen. You have to balance all other atoms. Then balance oxygen by adding water, balance hydrogen by adding H positive. After balancing all of this, then you have to balance the charge by adding the electrons here. If basic medium, then we do this. Okay, now we'll go through this. Okay, now I'll show you what exactly to do here. Right? Let's see and solve this. Let's see and solve this. Yes, everyone? Ready to balance it with me? Okay. So let's see if we are able to do this or not. I'm just erasing everything so that you know. Chalo, I can write it. Why then I have written this? Why I have to erase all of this? Chalo. Now from the starting we'll be doing it. Okay? From the bilkul starting, initial starting we'll be doing it. So what is the reaction that you will have? They will give you one reaction here. So first you will see what is the reaction that we have. Okay. Reaction is Fe2 positive plus CrO7 2 negative. Fe2 positive plus CrO7 2 negative. Cr2O7 2 negative, right? Then you can see that this is being converted to Cr3 positive and Fe3 positive. Okay. Balancing is very important because this you will use in DNF block as well. This is a reaction of DNF block that I told you, you don't have to cram the reaction. You can balance it yourself in the exam, right? So that's why now, firstly, first step is to see that identify the atoms undergoing reduction and oxidation. If you see here it is +2, here it is +3. Here oxidation number is increasing, that is why this is undergoing oxidation. This is undergoing oxidation. Here if you see, this will be +6 when you find this will be +3, and here it is undergoing reduction, oxidation number is decreasing, it is undergoing reduction. Now you will have to divide it into two half cells. Okay, you will divide it into two half cells here. Let's divide it into two half cells. First is the reduction half cell, other is the oxidation half cell. So how I will do that? Firstly, I will see this is Fe2 positive to Fe3 positive, right? This is Cr2O7 2 negative to Cr3 positive, right? Okay, now see this here what I am doing. I told you that after this you have to balance all the atoms except for H and O. Okay, all atoms you have to balance here. Now balance all the atoms, balance, this is 1, this is 1. This chromium is 2, so it also has to be 2. Now after this balance water, balance oxygen by adding water. This is 7 oxygen, so I'll have to add 7 water here to balance oxygen. Now after balancing oxygen, I'll balance hydrogen, and for hydrogen I will add 14 H positive here. Because hydrogen I will balance by adding H positive here. Okay, that is according to the step. Firstly, I'll balance all the atoms except for oxygen and hydrogen. Then I have balanced oxygen. After that, I'll balance hydrogen. In the last part, you will balance electrons. The charge should be same. Okay, so here what we have? Here what we have, Fe2 positive, 3 positive. So if I multiply this, if I add, what is the difference here? 2 to 3. What is the difference? I need to add 1 electron here. Moreover, because it is undergoing oxidation, so electron will be lost here, right? Here what I need to add? I need to add electrons or lose electrons. This is 14 plus 14 minus 2, that is plus 12. Here it is 3 to 6, that is plus 6. So that means I need to add 6 electrons here, right? This charge is plus 12, this is plus 6. So I need to add 6 electrons. That means I need to subtract 6 from here to become equal to plus 6. That means I need to add 6 electrons here. So what you can say, add 6 electrons here. Okay, you need to add 6 electrons here, right? Okay, add 6 electrons and that will work here. Now number of electrons here and here should be same. So here also I need to multiply it with 6, right? So that means here it will be 6 of Fe2 positive give rise to Fe6 of Fe3 positive plus 6 electrons. Here it is this equation that you have, right? Now you will add these two. When you add these two, what you will get? When you add these two, what you will get? Final answer will be 6 of Fe2 positive plus Cr2O7 2 negative plus 14 H positive, right? 6 electron will be cancelled here on both sides. Here it will be 6 of Fe 3 positive. Then here it is 2 of chromium 3 positive, right? Then it is 7 of water here. This will be the balanced chemical equation in the acidic medium. Is that clear, everyone? This will be there in the acidic medium, right? Okay. Now if you have to convert it into basic medium, for basic medium, what we will do? We will add OH negative here. So this is 2 of, wait a minute, this is 6 of Fe 2 positive plus Cr2O7 2 negative give rise to 6 of Fe 3 positive plus 2 of Cr3 positive plus 7 of water. So here you have already 14 H positive. So you will add 14 OH negative here and 14 OH negative here, right? So this will be converted to water because these two will make 14 of water. So you will write here 14 of water, right? This is 7 water. So 7 will come here and this will become 7 of water. So you will write here after this 7 of water. 7 of water here. And this is OH negative, and this will be deleted from here, right? Okay, so now answer will be this one. Tell me, is that clear? Tell me, is that clear? Okay, that's how you balance any redox reaction. Okay, just do one method, that is good enough for you. If you have not done any method, do this method. This is simple method. Okay. Some students also find the oxidation number method as simple. It's totally your choice. That is my personal choice. Okay. Done? Done, bacha? Yes. So I think we have done it. Right? Oxidation number method I am not teaching you. Only one method I am teaching you. But I am giving you this in the PPT. Right? Now let's see something very little things I am telling you about titrations. Okay, so this is more of cramming only, but still I'll tell you this so that you can remember this in an easy way. So there is one analyte and there is one flask, right? There is one titrant and that is in the burette. So this is called as flask and this is called as burette. So what will be there in the flask and what will be there in the burette? So always remember, analyte will always be there in the flask. That means this flask will always have analyte and this burette will always have titrant. It will always have titrant. And titrant is always known and analyte is always unknown to you. Now a simple way of remembering this is that Anita is a female. Anita means analyte, female means flask. And Anita is like unknown. Anita is busy. Anita is overthinking. Anita does not know who she is. She has so many mood swings. She that I want this also, I want that also. She's like right now she's unknown. She's just discovering herself, right? And this is titrant is Tarun. Tarun is a boy. That means burette. And boy is like, okay, I want this, I want this, I want that. Okay. I want money, I want money, I want money, right? Okay, so that is fixed. Tarun is known, right? Now this will always be there and we always say unknown and known we will equate and then we can say N1 V1 is equals to N2 V2. That means small n1 n factor M1 V1 is equals to N2 M2 V2. Then indicators. There are self indicators also. There are internal indicators also. In the self indicators, you have oxidized, in the self indicator, you have starch, right? So starch, when it is in the I2 form, it has deep blue color. When it will be converted to, when it will be reduced to I negative, it will turn into colorless. That means When I2 and starch is there, it will give you deep blue color. Okay. When I2, iodine is present as I2, and you put a drop of starch in it, it will show you deep blue color. Okay. Internal indicators are like KMNO4. That is internal indicator. Then there is bit of back titration. Back titration is, in this case, a very simple way of remembering this. There is Anita, there is Tarun, and there is Banita, right? Not Banita, I'll say there is which thing? Anything that you write that starts with B, that you eat. Berries. Okay, ma'am, too much hi-fi. Okay, let's say these are berries. So what happened, Diksha ma'am came and Diksha ma'am is like, okay, I have got some really good berries, right? So I'm like, okay, I'll give berries firstly to Anita. I gave like 100 berries to Anita, right? So now I know that the amount that I have is 100. I gave to it to Anita. Then I told Anita, Anita, you have not distributed it among other students. Anita is like, no. I'm like, why? How many you have eaten? Anita is like, I won't tell you that how many I have eaten. I'm like, okay, Anita, you will not tell me. I'll call Tarun. Tarun is innocent person. Tarun will be like, okay, ma'am, you had 100. Now I will see how many I am able to eat, right? I will see how many are the remaining out of 100. If we are left with only 60, that means 40 Anita has eaten. Same thing is here, right? So that means we'll say that when I have berries here, wait a minute. When I have berries here, let's say this is berries, okay? So many berries are here. Now some of them Anita has eaten. Anita has eaten. Anita is not telling me how many she has eaten. Tarun told me, ma'am, only 4 are left. Then I'm like, okay, 5 Anita has eaten. Same thing we are doing here. We are saying that we have some known, we have in the, there is 2 components. One is A and one is B, right? Other is T. So we are saying T is the titrant, A is the analyte, right? Now what we are saying, the equivalent of B is equals to, because we know that how much A plus T is equals to B, because total berries equals to how much Anita has eaten and how much Tarun has eaten, analyte and Tarun, titrant. So that means E of B is equals to E of A, E of, wait a minute, E of, right, I'm sorry. Yes. So E of B is equals to E of A plus E of T. That means E of A is equals to E of B minus E of T. So analyte, which is unknown to us, you will calculate this by how much total you have minus how much titrant has consumed. Okay, right? Then guys, this is ido and idimetric. Usually questions are asked based on this. Idometric means, in this case, firstly I negative will be oxidized here, right? This is 2-step mechanism. What will happen here? I negative in the presence of oxidizing agent will be converted to I2. Whenever I2 is there and you add starch, you see blue color, right? Then I2 will be reduced by adding reducing agent. Then this will be converted to colorless, because now I2 will be converted to I negative. That is 2-step, that means indirect idometric. Now in case of ID metric, what you will have I2 is reduced firstly. That means here in this case you don't have I negative. Directly you will have I2, you will add reducing agent here and it will be converted to I negative. Right? That is the difference between idometric and ID metric. Right? Okay. Then if you see in case of idometric, you have this thing. In case of idometric, firstly I negative is converted to I2. Then I2 is converted to I negative. That means firstly colorless will be converted to blue color. then blue color to colorless will be converted, right? Okay. Huh. So I negative is converted to deep blue color in directed by starch, and then I2 blue color by adding reducing agent is converted to I negative. That means it is converted to colorless. Okay. Then these are the last formula sheets. Again, very important. If they ask you very high level question, they can ask you questions from here. Formula directly remember. Volume strength of H2O2 is 11.2 into molarity or 5.6 into normality. They will give you the normality or molarity of the solution. Strength of H2O2 is equals to 34 into molarity, and percentage weight by volume is equals to this strength divided by 10. Okay, direct formulas you should remember. Then in case of Y% oleum sample, if they have given you like 108% oleum sample, you will say that, for example, 108% oleum sample is there. How much percentage of free SO2, SO3? There is a proper derivation, but only do formulas here. Okay, so this will be, if you say 108%, right? In that case, 80 by 18, you will say 80 by 18. Then y minus 100, that means 108 minus 100%. So this will be 80 by 8 multiplied by 8%. And that will be your answer. Okay? Done? Tell me everyone, is that clear? Now we are only left with electrochemistry, right? But I'll take break before that. Okay, tell me everyone. Okay, tell me. Now after this we'll do electrochemistry. Just relax for 10-15 minutes because electrochemistry is a big chapter and a very important chapter. There are so many different topics that we will study here, right? Redox was a very small chapter, that's why I solved it without any break, but this one is a big chapter. Okay, done? Shall I give you break now? Chalo. Now this is already 4:05 and I'll see you all at 4:20 p.m. Okay? I think by 5:30 we will be free. Okay, by 5:30 p.m. you will be free. Half an hour or 1 hour you will take rest, or maybe 2 hours you will take rest and study something else. Right? Okay, guys? Done. Chalo. So 4:20 p.m. I'll see you all after break. Right? Chalo. Okay, so yes, everyone in the chat box, I am back. Yes, students, everybody, tell me, break is over. It's very difficult to teach after break, I must tell. So, after break, the energy is like, I want to take rest, right? Okay, so tell me, ready? Everyone here, ready, ready, ready. Very, very good evening. Let's start. Yes. Okay, tell me one thing. We have CS tomorrow. Yes, I'll just take one more hour. Okay, I'll just finish it. Okay. Acha, tell me how many of you have your CS exam tomorrow? Because some of you must have taken some other optional, right? Or all of you have taken CS only. Yes, tell me. Fast, fast, fast. How many of you have taken? Say yes, me, if you have. Right? Because I think tomorrow's session is very important and I don't want that you guys miss on that session. Right? So I'll see if I could change it to evening or I'll then take the session on maybe 26th. Right? Because I don't want all of you. That's okay, still you are here, that's awesome. Okay, so let's see. Okay, so I'll tell you whether I'm going to take that session on the next day or what, right? Now let's talk about electrochemistry, right? I'll see if I can take it tomorrow evening. If I take it tomorrow evening, that is also good. If I take it at tomorrow evening, that is also good. Tell me. Tomorrow evening, then I'll start it by 4 p.m. Okay, then because 3 p.m. I'll have to start it. 3 p.m. I'll start. Because if I don't start by 3 p.m., then it is very difficult to complete those questions. Either I'll start it at 3 p.m. or I'll start it on the next day, that is 26. Because it's a very important session, right? Okay. Okay, students. So, yes. Let me just inform the students. Okay, let's see. Let's do. Okay, let's do. Poll I'll do. By that time, you think, and then I'll give you the poll. Right? I'll have to see if my schedule is free tomorrow evening or not. Right? Okay? Yes. So let's see this here. Electrochemistry, guys. In electrochemistry, there are 3-4 sections. First, you will talk about Daniell cell. Then we'll talk about Nernst equation. Nernst equation. Then we will talk about on the third go, we'll talk about Daniell cell, Nernst equation, then conductance, then cells, batteries, or I would say batteries. Batteries is last one. Then there will be electrolytic cell. Last one is batteries. Okay, batteries. Now let's see this. Let's see this and let's finish this off. Electrochemistry. So let's talk about this. In electrochemistry, firstly let's talk about Daniell cell here. So first is salt bridge. Salt bridge is a junction that connects anodic and cathodic compartments in a cell. Now we are saying that salt bridge is that thing which will connect anodic and the cathodic compartments in a cell. Okay. So what is anodic compartment? That you can understand by LOAN. Right? Acha. Instead of doing this, I'm gonna tell you from here only. Okay. So let's do it in a better way. Let's start understanding with this way. Okay. So see, if I talk about, there are two kinds of cell. First is electrochemical cell. Then the next one is electrolytic cell. Other is electrolytic cell. If I talk about electrochemical cell and here it is electrolytic cell, how we will do that? So in a electrochemical cell, what we will have, and in a electrolytic cell, what we will have, let's separate them out. So in an electrochemical cell, what you will have? Electrical energy, right? What you will have? Chemical energy will be converted to, chemical energy will be converted to electrical energy here, right? And here electricity is provided, electrical energy is converted to chemical energy in this case. And here if you see, in this case, this is also called as electrochemical cell, is also called as galvanic cell, that we are going to study. Here we talk about one thing, that is LOAN, that means loss of electron, is oxidation that occurs on anode, and anode is a negative electrode, cathode is a positive electrode. But in case of electrolytic, you have LOAP, that means loss of electron is there, oxidation is there, that is at anode, but this is a positive electrode, right? That is a positive electrode what you have, right? Now let's see one cell, that is galvanic cell. So in this case, anode is negative and cathode is positive. So what is happening at anode? At anode side, zinc will be losing the electron and becoming Zn2 positive, and 2 electrons it will be losing. In this case, copper 2 positive will gain 2 electrons and become Cu, right? That means what will happen here, if this is the anode, from anode, the anode electrode will lose electron and will go into the solution. That means the thickness of anode decreases. The weight of anode will decrease here, right? But in this case, what you have, this is copper electrode, copper ions from the solutions are gaining the electrons and are getting deposited on the electrode here, right? Are getting deposited on the electrode. This is what we call that thickness of cathode, right? Thickness of cathode increases here. So overall reaction will take place, and the electrons, because here it is losing, so electrons flow is taking place from anode to cathode, right? And the current is opposite to that, so current will take place from cathode to anode. Okay, this is the overall thing that will happen here. Now, if I talk about to complete the circuit, what will happen here? Because here more positive charge is there, because electrons are getting lost and more ions are getting deposited here. And here positive charge is decreasing. In this, positive charge is increasing. In this case, positive charge is decreasing. That means negative charge is increasing. So one is overall positive, one is overall negative. That means it is not electrically neutral. So to make it electrically neutral, what we will do, we will add here salt bridge. This is a salt bridge that we will add here. Now what we tell about salt bridge, that salt bridge is a junction that is connected anodic and cathodic compartment to maintain the electrical neutrality. Electrolyte that we use in salt bridge must be strong, so that 100% dissociation is there, right? And always remember, this is the anion, this is positive side. So here on the anode, what will happen? Anion will be deposited from electrolyte. So you can say the cation and anion of these must have this, and cation will be deposited on the cathode side and anion will go to the anode side. Why? Because this is positive, overall positive. So anion will go here. This is overall negative, so cation will go here to maintain the electrical neutrality. And then we say the speed of both cation and anion has to be same. Only then proper electrical neutrality will be maintained, otherwise it will not be maintained. The commonly used electrolytes are KCl and KNO3. Right? This is the overall reaction that I have already told you. 2 electrons will be cancelled and this will be the overall reaction that will be formed. Now this we have seen deflection in voltmeter because current was there. Zn2 positive increases, that we know. Zinc rod anode thickness is reducing, right? Copper thickness is increasing. Both half cells are electrically neutral because of the salt bridge, right? Now, when external voltage is applied on it, then if the external voltage is less than 1.1, it will work normally. If the external voltage is equal to 1.1, no electron flow, no reaction will be there. If the external voltage is greater than 1.1, then it will start behaving like a electrolytic cell. Which cell? Electrolytic cell. So electron flow from copper. Usually electrons are flowing from, see, if you see this here, electrons are flowing from zinc to copper. But in this case, electrons will start flowing from copper to zinc. Everything will be reversed here. And this is a very, very important point, where electrolytic cell starts behaving like a where electrochemical cell start behaving like a electrolytic cell, right? Then we have electrode potential. Now, if I talk about the electrode potential, two kinds of electrode potentials we have. On the oxidation half cell, we have oxidation potential. On reduction half cells, we have reduction potential. Right? In oxidation potential, we write it as, for example, A naught. This will be written in increasing oxidation state. So A to A2 positive, this is oxidation potential. And reduction potential of the same thing will be E naught, A2 positive to A. That will be the reduction potential. Because here what is happening, oxidation number is increasing, so this is oxidation potential. Here oxidation number is decreasing, so that will be called as reduction potential here, right? Okay. Now see this here, when we talk about, and now next thing here is, when we talk about E naught cell of overall cell, that is always calculated as E naught of anode reduction, E naught of cathode minus anode, wait a minute, E naught of cathode reduction potential of cathode minus E naught of reduction potential of anode, right? So here we are using reduction potential only, because usually the standard potential is reduction potential only. We take standard as reduction potential only, right? So E naught of cell is equals to E naught cathode minus of E naught anode, and we are taking both as the reduction potential, right? Then if I talk about this series, you don't have to remember this series at all, right? Just remember one thing here, that if I say reduction potential, it is directly proportional to oxidizing power or oxidizing agent, right? And it is inversely proportional to oxidation potential, and it is inversely proportional to reducing power. That means if something is a very good, something has very high reduction potential, then it will get reduced. If it is getting reduced, it will oxidize someone else. So it is behaving as a very good oxidizing agent. So that is why if I say fluorine has very high reduction potential, that means it is the strongest oxidizing agent. If I say lithium has the least reduction potential. So least reduction potential means it is a very good reducing agent. So it's the strongest reducing agent here. Okay, is that clear? Is that clear? Strongest, and this is the fluorine and lithium are important here. Okay. Now let's see the next one. That is some of the very, very important formulas that you have here. Right? Very, very important formulas. Let's talk about these formulas here. So first is E naught of cell, E naught of cathode reduction potential minus E naught of anode reduction potential. We are talking about reduction potential only. This is to calculate E naught cell, right? But when we want to calculate the EMF of the cell, we say EMF or E cell is equals to E naught cell minus 2.303 RT by NF log of Q. Or when you talk about standard temperature, then it is written as 0.0591 by n log of Q. Now, what is n? N is actually the number of electron lost. You can just write it here. N is actually number of electron lost or gained, right, in the overall reaction, right? Q is what? Q is actually product by reactants raised to power the stoichiometry. Okay, that is the reaction quotient. This is actually called the reaction quotient. You remember reaction quotient that we have solved in chemical equilibrium, that thing. E naught cell is solved like this, and that will be your E cell. Okay, that is called as Nernst equation. Now another formulas, that is delta G and minus NF E naught cell, right? So delta G and E naught cell is connected like this, and delta G and equilibrium constant are connected like delta G is equal to, you can also write it like this, delta G naught is equals to minus 2.303 RT log of Kc. Okay, you can also write it like this, right? Then we say that if I talk about delta G, negative means spontaneous. If delta G is negative, then E has to be positive. If delta G is positive, E has to be negative. If delta G is 0, E will also be 0. That means it will be at equilibrium, right? Now the next part here is conductance. Okay, everyone? Next part here is conductance. So let's talk about conductance now. In the conductance, what you will see, there are three terms. R is resistance, rho is resistivity, capital G is conductance, and this kappa is conductivity, and this G star is cell constant. Okay, now see, resistance is equals to rho L by A. If I say resistance and conductance are inversely proportional, this is 1 by G, this becomes 1 by kappa, this is L by A. So you can say L by A is nothing but it is cell constant, that is L by A. So you can write here, this is 1 by kappa, this is G star, this is G. So you can say L by A is G star, na? G, acha, this is 1 by G, that's what I was thinking. 1 by G is equals to 1 by kappa, this is G star. So G into G star is equals to kappa, that you can relate here, right? So from this formula, you can conclude this formula, right? Now the next question that students ask is, ma'am, what is the difference in conductance, conductivity? Ma'am, what is the difference in resistance, resistivity? Which is the doubt reduction potential? Yes, what is the doubt? You can ask me there, right? So Q is reaction quotient. Okay, yes. So if I talk about this conductance and conductivity difference, conductance, if I talk about this, for example, this bottle, right? If I want to see the conductance of ions in this bottle, that means full length and area I am talking about. But if I take this volume, this little unit volume, I only want to see the conductance in this unit volume, that is called as conductivity. That means conductivity is the conductance for unit volume, right? Okay, similarly resistance is for full length, but resistivity is for unit volume, right? Now let's see this kappa. Kappa, if it is in meter, then molar conductivity will be kappa by molarity into 1000, right? And similarly equivalent conductivity is kappa by normality into 1000. But this is highly used in chemistry, right? That will be more used in physics, and this is more used in chemistry. Where is this mosquito that is irritating me? So molar conductivity is equals to kappa into 1000 by molarity if it is given in centimeter per ohm centimeter, right? Now next thing is, when dilution increases, concentration decreases. We know that when you add water, concentration will decrease, We say that in that case, kappa will decrease, conductivity will decrease, because conductivity is about that unit volume. In that unit volume, if you see, right, earlier you had how many ions? Earlier you had, let's say, these many ions. So many ions you had. Now what will happen? When you add water into it, some of the ions will be displaced here. Why? Because in place of those ions, now water molecules will be added. That is why conductivity will decrease. But molar conductivity will increase, because kappa into volume is molar conductivity. Na? Molar conductivity is not about specific volume. Molar conductivity is about 1 mole. This is about 1 mole. So for 1 mole, number of ions are increasing. In 1 mole, the number of ions that will remain, sorry, if you see, number of particles will remain same only, because molar conductivity means 1 mole only. You can't change the ions here, but volume is increasing here. Earlier 1 moles of ions were here in this much place. Now 1 mole of ions need this much place. That is why molar conductivity increases, because molar conductivity is inversely proportional to molarity. That means it is directly proportional to volume. So as volume increases, molar conductivity will also increase here. Okay, because they ask you assertion reasoning questions based on this, right? That's why I'm giving you the explanation for this, right? Then guys, we are saying that molar conductivity decreases, but there are two things. One is strong electrolyte, other is weak electrolyte. This slope is there for strong electrolyte. Strong electrolyte has 100% dissociation. It has 100% dissociation. We know that as concentration, as dilution is increasing, concentration is decreasing here, molar conductivity will increase, right? Because when dilution is increasing, molar conductivity is increasing. So what we can see, as concentration is decreasing, dilution is increasing, molar conductivity is increasing, and it will be infinite at infinite dilution. When you have done infinite dilution, then molar conductivity will be uh, this, not you will represent here. Infinite molar conductivity or limiting molar conductivity, this is called. Okay, this is possible for strong electrolyte. But in case of weak electrolyte, what will happen? In case of weak electrolyte, we saw something very different. We saw that in case of weak electrolyte, no 100%, partial dissociation was there. Partial dissociation is there. So what is happening here? As you increase the dilution, it is increasing because number of ions are also increasing. Number of ions dissociated also increases. So sudden increase is observed. So what is happening here? It is increasing as you're adding water, molar conductivity is increasing. But here what is happening? As number of ions are also increasing with weak electrolyte. Say weak electrolyte, weak electrolyte is not 100% dissociated. When you add water, it is moving towards behaving like a strong electrolyte. Now dissociation is also increasing in the weak electrolyte. Not only the volume, but also the number of ions are also increasing. That is why you will see extreme increase in the molar conductivity, that it becomes parallel to the y-axis, and that is why no intercept you will see. So you will not be able to find the infinite molar conductivity directly. Okay, so infinite molar conductivity you won't be able to find directly. So what you can do about it? So for that we have a law that is called as Kohlrausch law. Kohlrausch law, simply I'll give you a simple way. Firstly, Kohlrausch law states that, for example, I want to find out the molar conductivity of CH3COH. That can be equals to the molar conductivity of NaCl. Wait a minute. That can also be molar conductivity of CH3COONA plus molar conductivity of molar conductivity of HCl minus molar conductivity of NaCl, because this Na will be cancelled by this Na, this Cl will be cancelled by this Cl, and you will be left with these two. That means we are saying the limiting molar conductivity of cation and anion is actually the sum of both. That means we want to say that molar conductivity is actually equal to CH3COO negative plus CH3 plus H positive. This is the thing, that this molar conductivity is equals to the sum of individual ion molar conductivity, that you can calculate like this. Whatever question is given to you, accordingly you will understand, right? Now next is this particular thing. We say alpha is equals to, before this let's understand this thing here. We say alpha is equals to molar conductivity by limiting molar conductivity. Limiting molar conductivity you will find with Kohlrausch law, and this you will find by kappa into 1000 by molarity. Okay. Then we also know Ka, this is also another important thing. Ka is equals to C alpha square by 1 minus alpha. This is from ionic equilibrium. We have done this in yesterday's class. How for monobasic acid, dissociation constant is Ka equals to C alpha square. And if alpha is very small, Ka will be equals to C alpha square. Okay, this we have done. But this dissociation constant in terms of this is equals to C molar conductivity square by molar conductivity at limiting molar conductivity multiplied by limiting molar conductivity minus of molar conductivity. This is also very important, and they have asked you this in one of the PYQs, right? Okay, clear everyone? Done? Acha. See, now guys we'll talk about electrolytic. Now very few things are left, and mostly things regarding your cramming part is left. So I'll just do it very quickly because you have your exam tomorrow, right? See, now what exactly happens in case of these cases now, when you have electrolytic solution? I'll tell you in electrolytic solution, firstly what will happen. I'll just make a diagram here, okay? First, you should know what is exactly happening in electrolytic solutions. Okay. See, if I see this is in the electrolytic solution, first thing is only one beaker is there. Let's say I am making electrolytic solution for, I'll do it for one thing, that is, I'll do it for copper. Okay. I'll do it for this one. I'll do it for electrolysis of aqueous copper sulfate in copper electrode, right? So what will happen here? Here you will have two electrodes, okay? Two electrodes will be there. One will be cathode and other will be anode, right? Two electrodes I have taken here. Now, this is the solution that you will have. This is the solution that you will have. Now, instead of taking this solution, can I do this thing? Wait a minute. Wait a minute, huh? I just don't want to erase it again and again. So just give me a second. I'll take this speaker. Okay? I think that would be better, so that I don't have to erase it again and again. Oh, chalo. Now this is the beaker and I have two electrodes. One is cathode, one is anode. Let's say this is cathode and this one is anode. Okay, let's say this is cathode, this one is anode. Now see what I will do, right? Now we know one thing, that in the electrolyte, LOAP is the thing. That means loss of electron occurs at oxidation, that is a anode, but anode is positive electrode, right? So if I take it like this, I'll keep the positive electrode here. I'll keep one positive electrode here, right? So this will be, let's say this is the positive electrode, this is the anode, this is the positive electrode, okay? And this is the negative electrode that we have, that is cathode, okay? Cathode is the negative electrode here, right? Now what I am saying that here, here they are saying the electrode is of copper only, right? The electrode is of copper only, and this solution is CuSO4. CuSO4 means Cu2 positive and SO4, two negative ions are there. Now see what will happen at cathode and anode. At cathode, what will happen? See, at cathode, what I can say is Cu2 positive is there in the solution, right? It can gain electron to become Cu. What else can happen? There is also aqueous, that means water also can be converted to H2. Remember, always water at cathode is converted to H2 and water at anode is converted to O2, right? Then there is another thing, yeah, these two things can happen here, right? At anode, what can happen? At anode, three things can happen. Water can be converted to O2. Then Cu, because copper electrode is there, it can lose electrons and become Cu2 positive and 2 electrons. And another thing that can happen here is SO4 2 negative is converted to S2O8 2 negative. You know what will be selected here? There are so many different cases. Just remember what will be selected. At cathode, that thing is selected which has high reduction potential. At anode, that thing is selected which has high oxidation potential, right? Which has high oxidation potential. So that means here that will not be selected, this will be selected. Now this is from the values only, you don't have to remember the values, just remember what is selected. These had lower oxidation potential, this had the highest one. Here oxidation potential is 0.34, which is highest. Here reduction potential is minus 0.34 and this is 0. Wait a minute. Reduction potential here it is 0.34 and this will be minus 0.34, that is the oxidation potential. So here this is selected. That means what is happening here at cathode, copper, okay, if I say this is cathode, this is anode, right? What is happening here? At cathode, Cu2 positive ions are eaten up by this cathode. Okay, they are eating, and the thickness of cathode is increasing. Cathode thickness is increasing, right? Because it is eating it, right? And at anode, what is happening? At anode, it is losing. At anode, copper, this is actually getting converted to Cu2 positive ions in the solution. That means anode thickness is decreasing, because at anode this electrode is getting converted to ions. Here ions are getting converted to electrodes. So you know what we take in electrolysis, what is the use of electrolysis? That we take anode as impure. So that at anode all the impure electrode is getting converted to ions. Then these ions will catch 2 electrons at cathode and they will be converted to pure electrode. That means what is the cycle? Here this will dissociate and it will be converted to Cu2 positive ion, and here you will have the anode mud, that is the impurity. This will be the anode mud, that is the impurity. Tell me, Is that clear? Is that clear, everyone? Done? Done, everyone? Yes. Yes, everybody here. Yes. Done? Let's see now, simple things are left here. That means like here we have chosen in the similar way in every single reaction we have chosen something. For example, in aqueous sodium chloride, sodium can be converted to Na or water can be converted to H2. At anode there will be ion, so Cl can be converted to Cl2 or water can be converted to O2. But what is selected? This is selected and this is selected. So at cathode you have H2 and at anode you have Cl2. Similarly, in case of aqueous copper sulfate, when copper electrode is not there, in that case at cathode you have Cu positive to Cu or water to H2, out of which this will win here, right? In this case you have SO4 to S2 this or water to oxygen. Copper will not be there because you don't have copper electrode, so this will win. So you have anode O2 and cathode Cu. Next, this I have taught you in detail only. Electrolysis of silver nitrate and silver electrode. At cathode silver to Ag, that means iron to Ag, iron to neutral atom, metal. Water can be converted to H2 because aqueous always means cathode, water can be converted to H2 and at anode water can be converted to O2. At anode water can be converted to O2. Nitrate ion does not show any oxidation because it is in the highest oxidation state, that is +5. Okay. At anode there is also silver. If I say silver electrode, same like in case of your copper electrode, this case that I have taught you in detail, here also you will have silver electrode that can be converted to Ag. Out of this will win and this will win, and this is also purification of silver, like we have done purification of copper, right? Okay. Then if I say you don't have silver electrode, then same what we will do, right? In this case, at cathode always cations will be there, so Ag positive will be converted to Ag. At anode anion will be there, but this anion has no oxidation. And water will always at cathode will be H2 and at anode will be O2. Out of this, which will win? This one will win here, and here there is only one possibility, that is O2. So answer will be Ag and O2 is formed, right? Then the next one is electrolysis of aqueous sodium sulfate. Sodium is Na, sulfate is this. It is converted to Na, here it is converted to oxidize to S2O8, sorry, S2O42 negative. Now, at anode water to at cathode water to H2, at anode water to O2. Just remember which will win. This will win here, this will win. So H2 and O2 is formed. Okay. Electrolysis of aqueous sulfuric acid. You have here cathode C from sulfuric acid. Sulfuric acid will give you H positive. So H positive to H2 or water to H2. Both are giving you H2 only. So H2 only will be formed. But from which thing? H positive to H2 has 0 electron potential and this one has 0.84. So this one has higher electron potential. That is why this one will win. At anode, SO42 negative to this will never win. It has such a low oxidation potential, it will never win. Okay, so water to O2 has higher potential, that is why it will win. Now you are like, ma'am, do I have to remember all of this? No, I just told you that this is the full criteria how we are choosing things, okay? But in the end, remember this particular table here, okay? Yes, everybody tell me. Just remember this last table here. Very good, electronics engineer. I think if you listen to my class one day before the exam, then the credit also goes to you, right? I just revised what you have already studied, right? So hard work is yours, that has paid off, okay? So now guys, let's talk about Faraday's law, and in the next class, that is your PYQ session, we will also discuss the Faraday's first law and second law, right? So here Faraday's first law, the amount of chemical reaction which occurs at any electrode during electrolysis by current is proportional to that. Now I'll just write it like this, okay? Instead of just giving you this, let's see how we are going to write it. See, we are saying weight deposited is directly proportional to charge, that is Q. And here proportionality sign is Z, that is electrochemical equivalence. Z is equal to electrochemical equivalence. Equivalent. Okay. Now Q is nothing but current into time, right? And Z is also written as, Z is also molar mass by, or you can just say, wait a minute, Z is equal to so sorry, Z is equal to equivalent weight by Faraday. This is I into T. Equivalent weight is nothing but it is molar mass by N factor, and this is already Faraday, and this is I into T, and this is a full-fledged formula that you have. Okay, this is a full-fledged, oh, what just happened? Okay, so this is a full-fledged formula that you have here. Okay, everyone, got it? Right? Now let's see. This is the formula that we will use in numericals for first day of Faraday's first law. Okay. Then second law states that if you have so many electrolytic cells connected in series, then the ratio of weight by equivalent weight of all of them will be equal to each other. Very simple. Okay. We'll see the formula. We'll see the numericals based on that. Now guys, we are just left with the theory part of it, right? This is majorly little bit only I'll have to teach you, because frankly this is full cramming. This is like full proper cramming that you see, right? If I'm still here, that means this class is helpful. Yes, definitely. Right? Now see, you have primary batteries, you have secondary batteries. Primary is someone who is prime. Prime is someone who is like, I cannot be used again and again. Okay, I am very akdu, I am very attitude, full of attitude. I am primary, I am not secondary, I am the first person, I am always primary. So how you can reuse me? No, I will be used only for once, and then you can throw me. Secondary is like we use in our mobiles, everywhere. We recharge. We are not like, okay, I'll purchase the battery and after 1 month battery is discharged and I'll purchase new battery. No, you charge your battery on daily basis. Why? Because that is secondary battery. So secondary battery is rechargeable. Primary battery is only used for once, right? Here examples are dry cell, like Leclanche cell and mercury cell. This is different cell and this is different cell. Here for secondary battery, it is lead storage battery or nickel cadmium battery. Lead storage battery is also used in inverters. Okay, so let's talk about that. So first is Leclanche or dry cell, right? Leclanche cell, guys, here you just have to remember all the reactions. The reaction at anode, the reaction at cathode, right? The overall reaction, the electrolyte, everything. Now here 1.5 volt is used, that means very less. Now in my this watch, I have a primary battery because I will not recharge this watch. There are smart watches that will be recharged, but this is not rechargeable, right? I will like replace the battery here once it goes out, right? So cell potential is 1.5, used commonly in transistors and clocks, right? Then you have this one at anode. What is happening at cathode? Electrolyte, everything. This is used in hearing aids and watches because very less potential should be there. It is connected to our body, so very less potential should be there, right? Then bacha, there is lead storage battery and nickel cadmium battery. You should know overall reactions, okay, that you will write and learn it yourself. That is your homework, right? So lead storage battery. This is the most important battery here, right? So anode, what is happening at cathode, right? The reaction you should remember, electrolyte, very important. On charging, the battery reaction is reversed. So this actually, now here this reaction is for discharge. This is what they ask you. This is discharge reaction when it is getting used up. This is also the reaction of discharge for nickel cadmium cell, because both are rechargeable cells, right? Now when you ask about charging reactions, that will be reverse of both of them, right? Used commonly in automobiles and inverters. And yes, okay, that is nickel cadmium. Now the last page, that is hydrogen fuel cell. So what it is, this also they ask you question on this. So see, hydrogen oxygen are bubbled through porous carbon electrodes into concentrate to form this. So what exactly, from hydrogen and oxygen you form water here. What is the overall reaction? You should remember cathode and anode reaction also. At cathode, O2 is being converted to 4OH. Here H2 is being converted to H2, and this is both the reactions are very important for you, right? Electrolyte is aqueous NaOH. Electrode is carbon with finely divided platinum or platinum, and increasing by to increase the reaction rate. Catalysts are finely divided metals, right? The cell runs continuously, so the reactants are supplied. So basically, this cell is used in Apollo space missions, right? In space, these cells are used basically to produce water, as well as because there you can't have proper supply of water, right? So for that, this particular reaction is used, right? Okay, tell me. Watching video while eating Dominoes. I should also go now and eat. Now you're giving me cravings of Dominoes. Yes. Tell me, tell me, tell me. Now everything is done. Theory part is done, guys. So as like in from my side, I have completed like full theory of physical chemistry. I don't think so. I have left anything, right? So now there is question part, because physical chemistry is nothing if you don't do practice, right? So now I'll tell you, if I'm taking the class tomorrow, I'll put a poll on JEE English, right? And yes, firstly, though, I'll see that what is the answer to that poll. Accordingly, I'll take the session, right? Whether I'll take the session tomorrow or day after tomorrow. By the time I'm talking to you, I'll just save this, right? What is it? Physical chemistry 12, class 12, right? So I'll just save this because it's a big PPT. Okay, tell me. Beta, physical chemistry alone will never work. You'll have to apply. If you're very smart, right, super duper smart, then obviously if you have gone through like questions and or somewhere, then definitely come to my PYQs class. You will get an idea how to apply these formulas. Just by looking at the formulas of PC will not work. You have to understand how to apply these formulas in the exam. So that's why I'll be only picking the PYQs, right? The PPT is already ready for PYQs, right? So I am thinking that 100 questions are there, but out of those 100 questions, what I'll do, I'll pick up like some questions similar questions I'll give you for homework also. Like maybe I'll see how much amount, right? And every single question that I'll take here will be different. Repetition of questions I'll not do. I'll only give you category of question, that this is one category, this is next category, so that you know how to apply these different types of questions. Okay? Yes. Chalo. Ma'am, my apprentice is on to give some motivation. Beta, motivation is only one thing that you study, right? If I can only tell you one thing, that right now, right, Every single minute matters the most, right? Every single thing that you're learning matters the most. You never know what you're learning will directly come in the exam. PYQs are repeated, go through PYQs, right? Don't look for that portion that is not repeated. Obviously, in every exam, there will be questions that will be new, that will be fresh. That's what make it competitive exam. But there are so many questions in maths as well, in physics, in chemistry that are repeated, right? That is why go through PYQs. That will help you in the last few days. PYQs is the game. And those who have done PYQs enough time, go through mock tests. That is the only motivation that I can give you. Because just by sitting and having dopamine that yes, I can do it, will not work. You have to make it in the action. Only then you will achieve something, right? So study, study and study, right? Okay then, guys. Bye bye. Take care. I'll see you all in the next class for 100.